centers. So we'll be starting shortly in 5 minutes.
ये प्रेजेंटेशन आपने बनाई है या स्पेशलिस्ट रखे बनाने की? प्रेजेंटेशन मैंने आपने बनाई है खुद की है?
ये मेरी होती है जिन
बहुत अच्छी बनाई है, तभी मैं देख रहा हूँ।
ये सारी प्रेजेंटेशन मतलब ये कंपाइल करता जाता हूँ, जैसे एक दिन में तो नहीं बनती।
हाँ
जैसे
Participants at remote centers, participants in our studio, and our esteemed speaker, Dr. Khatri, Dr. S.S. Banwar, Professor and Head of Mechanical Department, and Dr. B.S. Pabla, Professor and Head of Educational Television Department. I welcome you all on behalf of our institute to this ICT-based short-term course on recent trends in automobile engineering. In this course, we have presently 6 centers connected. So I will invite the centers one by one. First, we have from Padal Institutes, Ropar. Hello.
Hello. Good morning, sir.
Good morning.
This is Dr. Rakesh from IT, sir.
Can you hear our voice clearly?
Yes, yes, sir.
Okay, because actually your voice is not very clear on this side. Probably our technical people are saying that maybe you are using an external microphone. That is why that your voice is not reaching us clearly. So in case if you use the laptop, that will be clear. So can you please tell me how many participants are in this course?
We are 10 participants from IT Brother.
Sir, can you please come close to the computer or the laptop? Yeah, and use the microphone of the laptop only. That will be.
Hello.
Yeah, now it's very clear. Yes.
Sir, we are 10 participants.
From mechanical department or it's a mix?
It's only engineering department, sir.
thank you so much. Next we go to
Thank you.
Riyadh Bara University.
आपने माइक्रोफोन ऑन कर दिया?
Good morning.
गुड मॉर्निंग।
Good morning, Professor Tripathi.
जी सर।
Hanji. So, how many participants will be attending this course?
सर अराउंड 20।
Okay, 20.
20.
And so, all from mechanical department, or is it a mix of all the departments?
या मैकेनिकल एंड ऑटोमोबाइल।
Mechanical and automobile. Okay, that's good.
Yeah.
Thank you so much. Next, we go to SRM University, Ghaziabad.
Yes, sir.
At SRM University, please. Next, we go to HMR Institute of Technology and Management, Delhi.
Hello.
Hello.
Yes, sir. Good morning, sir.
Introduce yourself,
Pardon, sir.
please.
Pardon, sir.
Your name, please.
Mohammad Izhar.
Okay, so you are from HMR Institute.
Definitely, sir.
Okay, so how many participants are attending this program?
Around 40.
Hanji?
Around 40.
40, 40.
Yeah, of course, sir.
So, from which branches?
Mechanical and triple E.
Mechanical and electronics and electrical engineering. Okay.
Yeah,
Thank you.
definitely. Okay, thank you.
Next, we invite Shri Chaitanya College of Engineering, Cream Nagar, Hyderabad.
Good morning, sir. Sir, we have around 23 participants.
Yes, sir. Okay. And the departments?
All are from mechanical.
All from mechanical. Okay, thank you. Is it Dr. Prasad?
Yes, sir.
Okay, thank you, Dr. Prasad. Next, Jodhpur Institute of Engineering and Technology, Jodhpur.
Hello. Hello.
Hello.
Good morning, sir.
Morning.
Sir, I am Manoj Kumar from DIT Jodhpur Mechanical Engineering Department.
So, Manojji, how many participants are attending?
Sir, around 40 to 45 candidates are enrolled, and all are from Mechanical Engineering Department.
So, all are faculty members?
Yes, sir, faculty members.
Thank you. Then we come back to SRM University, Ghaziabad again. SRM University, Ghaziabad.
पूछ लिया ना?
We have Dr. Atul Kumar or Professor Mittal.
जोधपुर में? हाँ, बस?
अभी 6 है.
सर चंडीगढ़ वालों को रात को मेल मिली है तो वो कह रहे हैं अभी हमें टाइम मिलेगा।
ओके, बाकी लक्ष्मी इंस्टीट्यूट,
नहीं सर, वो मना कर दे.
सीएमआर,
सर जो सीएमआर है उनकी नेटवर्क इशू आ रहा है, वो भी थोड़ी देर में
ओके, बीके बिरला इंस्टीट्यूट,
DK Birla has
उन्होंने मना कर दिया।
they have
मना कर दीजिए।
so we have 6
सर
centers.
उसके अलावा एक सरफ होगा अभी होना है उनका सरफ इंस्टीट्यूट
ओके,
उनका भी कॉल आया है सर जी
ओके, टेल देम कनेक्ट करेंगे।
Okay.
हम शुरू करते हैं।
So presently we have 6 centers and 2 more are likely to join. So to throw light on this course, first I will invite Dr. S.S. Banwar, who is Professor and Head of Mechanical Department.
Yeah, good morning, all participants sitting here in the studio as well as different centers. In fact, this is a course, and every year we are conducting with the expertise of professionals from industry. And in fact, our earlier director, Dr. Punia, was basically from this field, and he, in fact, motivated us to conduct this course. And in that process, we have developed good contacts with the automobile industries in Gurgaon and Chandigarh. So, in the light of that, we'll be conducting this course. And if you see the timetable which the coordinator, Dr. Dhami, might have sent you, the experts are from different areas. We have Dr. Khatri from Membesis Technovation Gurgaon, and the engineer P.S. Virdi, he is a director, research to product industry Mohali, having vast experience in the automobile sector. Then there are experts from Isuzu, Ropert, from Medhavi Center for Automotive Research, and Dr. G.K. Sharma, a well-known personality in the automotive sector. He is a consultant to many industries in Faridabad. And the roadmap for this program is that today Dr. Khatri will be taking sessions on engine management systems, and then he'll be talking on the alternate fuel technology in the afternoon. And tomorrow we have invited Virdi, who will be talking on challenges to automotive industry, performance and emissions. And then Dr. Dhami will be covering some automotive sensors which are used in automobiles. And on Wednesday, then we have morning sessions taken care of by Maninder Sani, a experienced engineer from SML Isuzu. And he'll be talking on vehicle performance estimation, new transmission technologies. And then in the afternoon, Mr. Virdi will be covering some special material which are used in the automobile sector. On Thursday, then we have kept a session with Yogesh Kalia in the morning. He'll be talking about the technology roadmap which the automobile sector is adopting for moving from BS4 to BS6. And Thursday afternoon, then I'll be taking a session on autonomous vehicles, because it's a topic nowadays. A lot of talk is being centered around various manufacturers going in for autonomous vehicles. And then Friday, we have a morning session with Dr. G.K. Sharma. We'll be talking about after treatment technologies to meet BS4 emission standards. And on Friday afternoon, we have kept a validity section, getting feedback from you people. And this is the timetable which we have framed. In fact, I have told you the roadmap, how we'll be going about this course. In fact, I expect that in between, if you want any specific session or any change in the content of the course, do let us know so that we can make the necessary amendment in our program. And this is a lot I want to say about this course, Dr. Dan.
Thank you, Professor Banwar. Now I'll request Dr. B.S. Kawala, Professor and Head of Educational Television Department, to please tell us about the benefits and the technology which we are using for conducting ICT programs.
Okay.
Very good morning to all the participants in the studio as well as the remote centers and the experts, Dr. Khatri, Professor Banwar, Professor Dhami. They have started introducing me as professor and head of ETV only. They don't talk about me that I am a professor in mechanical engineering also. So they don't want me to talk about mechanical engineering. Anyway, as to increase the approach and the benefit to the teachers who are unable to come to the institute in large numbers, we introduced this program through ICT, Information Communication Technology, in 2012. We are connecting a large number of programs through ICT so that maximum number of teachers throughout India. It is not restricted to one or two states. Throughout India, people can connect and benefit from these programs. The idea behind this is that you don't have to come to Chandigarh. You don't have to leave back your families. You don't have to miss the classes also. Up to 10 o'clock, you are in your office. Maybe after 4 o'clock, again, you can go back to your office and do your routine work. At the same time, in between, because for ICT-based programs, we have reduced the timings also. It starts at 10 o'clock and finishes at 4 o'clock. Almost 4:15, we try to wind up all the programs. The idea is that maximum number of people should benefit, and at the same time, we are trying that we get the experts from industry. We get the real experts who are working in these areas, who can interact with you, who can tell you what is happening in industry and what we should also be doing in the classroom. So this is one of the programs in IC Engines which we started, and we are connecting every year. Similarly, we are connecting many programs. The infrastructure required we have created at this end, but at your end, at the remote center end, we do not need much infrastructure. A laptop, a good quality internet connection, laptop with camera and mic. That is all. Maybe a projector also with you. That is all what you need. Then this being two-way communication, you can ask as many questions as you want. Please do ask questions. Experts are real experts, we have called. So I request you to interact with the experts. Let it not be one-way communication that the expert is speaking, because unless you ask questions, expert will not be able to interact. So make it very interesting and interactive. My only request to you is, please ensure, the coordinators at the local centers, please ensure that the participants are available, because a lot of inputs we are trying to give in these programs. Unless you are seriously taking these programs, it is of no use. So please ensure that participants are available throughout the day on all the 5 days. In addition, we are in the process of finalizing the what you call it as operation plan for the next year, or you can call it as training calendar for the next year. If you want any programs to be connected which are of need to you, which you are feeling difficult, or you want to upgrade your faculty, you can email to us at director@NITTTR.CHD.ac.in, so that we can incorporate those programs in our training calendar. So with this, I hope that you will all benefit. The program will be informative and of use to all of you, and you will cooperate with us and ensure that the participation at your end. Thank you very much.
Thank you, Professor Pavla. Well, Dr. Pavla said he is professor in mechanical, but today I wanted him to focus on the reach of the educational television and the benefits that we derive from this. So thank you, sir. And Dr. Pavla has also given a very good advice to the participant, and please do interact. That is very necessary. The industry experts have come from far off places. They are very busy people. It is not easy to catch hold of them. So please, as they say, make hay while the sun shines. So please do ask questions. So now, today our first session is on an engine management system, which will be taken care of by Dr. D.S. Khatri.
Monica.
So Dr. Khatri is founder director
Yeah,
of Vantage
desktop पे डाल
Technovation Gurgaon. His company consults many automobile companies in the NCR region. Dr. Khatri completed his masters in thermal engineering from Delhi College of Engineering in
वैसे ही।
91 and
EDF.
PhD from IIT Delhi in 1995. He has been visiting research fellow to University of Manchester Institute of Science and Technology UK, Imperial College of Science and Technology London, Cambridge, and Oxford University
वो चलो
UK.
लंच में डाल लेंगे।
In 1997, he joined European Commission in Rome University, Rome, Italy. In 98, he joined R&D of Maruti Suzuki India Limited, Gurgaon. In 2006, he joined FEV Germany, a company engaged in design and development of advanced engine and powertrain concepts, as technical head India operations. He is presently a technical advisor to new projects to ASK Automotive Gurgaon. Then he is also very closely involved with IIT Delhi. He is also guiding PhD work in IIT Delhi and tech projects in IIT Delhi, and he has also published more than 40 research papers in national and international journals and conferences, and he also has 2 patents to his credit. So we are lucky that Dr. Khatri is here today. So now I will request Dr. Khatri to please deliver his talk on engine management system. So please.
Yeah, good morning to everyone. And thanks to Professor Dhami, Professor Benwet, and Professor Paola for giving me the opportunity to interact with you young and dynamic engineers. Okay, before understanding the engine, we just try to understand what is an engine, because today we will talk about the engine management system. Okay, now can you just tell me what you understand about the engine? What is an engine? You will bring here.
Yes. So otherwise a battery lecture will be.
So I will change whenever required. Right. Engine is a energy conversion machine, right? Which convert the chemical energy which is in the fuel into heat energy, then subsequently heat energy is converted to mechanical energy, right? Now, similarly, to convert this, what you need any fuel, we call it hydrocarbons, right? Like petrol, diesel, LPG, any composition which consists of hydrocarbons. And what else you need? You need fuel, and then you need oxygen or air, right? Air we are taking, and oxygen is used to oxidize and the combustion take place. CH4 means plus oxygen, CO2 plus H2O is the outcome, and you get the heat energy also, depending upon the calorific value of the fuel. A internal combustion engine inhale the air and fuel is injected or mixed in the air. Now, to make it more clear, let me understand, we have a beautiful engine. Everybody has a beautiful engines. This is your body. What you do? You are just taking carbohydrates. Any kind of fuel you take, it is a carbohydrate, right? And the carbohydrate consists of carbon and hydrogen. And you inhale, what you inhale? Air. And that air, when it get inside, it break up that carbohydrate into CO2 and H2O. So when you are exhaling, some part of oxygen is converted into carbon dioxide and there is a water vapors.
Now, how much fuel you need whenever you want to increase the power of the engine? Like suppose you want to have more energy. It is not like that you eat more and you will get energy. Even your stomach may be in problem, right? Similarly, it is not necessary that you give more and more fuel to the engine. It will give you the more power. It is not true. Whenever you want to increase the power of the engine, at that time, we have to increase the air also. So air and fuel, the quantity of air and what time I should inject the fuel, what is the quantity of the fuel which I have to inject, that is very critical. Engine management system is about to control all these parameters, right? So that if you remember, like earlier, we have a carburetor. You know that carburetor was used to mix the air and fuel. Now, if we come to the engine, because my more talk will be revolving around the spark ignition engines, because there are two categories of engine. One is the petrol engine, one is the diesel engine. Petrol engine is a spark ignition engine, diesel engine is a compression ignition. And sometimes to make it more clear, so that you remember that, you can also categorize like spark ignition engine. It's sort of a arranged marriage. There are two types of marriage, arranged marriage and love marriage. So that you can recall, because it is easy when you interrupt with the story. So arranged marriage is like, because marriage between air and fuel. So when we have to mix them properly. So in spark ignition engines, I am mixing the air and fuel before entering into the combustion chamber. Are you understanding? Yes. Like in the intake manifold, air is coming. In the intake only, I am injecting the fuel, so that your mixing take place before mixture goes to the combustion chamber. And in the combustion chamber, at appropriate time, we are giving the spark, so that ignition is combustion take. So it means there is a time before happening to the combustion, there is a time so that air and fuel can mix with each other, they can understand each other, and they can make a optimum ratio and good mixing conditions, right? Because mixture preparation also take time. Suppose you are adding sugar in the milk or tea, then you have to stir it. Why you are stirring? So that mixing is proper. So similarly, air and fuel, I have to mix it properly by creating some turbulence or by creating some phenomena, so that air and fuel are mixed, having a homogeneous mixture. So this is the arranged, means before initiating the combustion, both are allowed to meet and mix. This is a love marriage. You understand each other. In arranged marriage, diesel engine is an arranged marriage. Like air is already in the combustion chamber and you are injecting the diesel fuel directly into the combustion chamber. You don't allow, there is a very little time for the mixing. So immediately it is a heterogeneous engine. So I think with this example, maybe it may be easier to understand. That is the basic fundamental difference between the petrol engine and diesel engine. Now, the important thing is that we understand what are the fundamental requirement of the engines. Like we have mentioned, we need a, so my talk will revolve around the petrol engine, and petrol engines are used in motorcycle, in three-wheeler, in all type of cars. Mostly they are spark ignition engines. Heavy duty application, trucks, buses, generally they have the diesel engine, but nowadays you can find cars also in the diesel engines, right? So we talk about the engine management system related to the spark ignition engines. Let me understand the basic properties, basic requirements of different aspects of the engines. Now, as it has been indicating that, and we have discussed that air is one of the very important requirement. Whenever you want to develop more power, it is not the fuel, it is the air which you have to increase. And you can understand even engine specifications are specified in cc. This is 100 cc engine, it is 200 cc engine, it is 1000 cc engine, it is 2000 cc engine. That cc, do you know what it means? That cc, cubic centimeter, and what physical meaning it has? Volume of cylinder. So, and volume of cylinder is filled with yeah. So basically, it defines the how much air you can suck in, because fuel quantity is negligible as compared to the air, right? So it is the amount of air the engine can suck. More air it can suck, more it can produce the power. Is it clear? So we have the air, then depending upon the type of fuel, we need a certain amount of air and fuel ratio. Suppose it is a petrol fuel. What is the air fuel ratio we need for combustion? How much? 17:1. Anybody else? 16:1. Anyone else? So we get two figures now. One is 16:1 and 17:1. Anything else? More precisely, it is around 14.7:1. We call it stoichiometric air fuel ratio. Stoichiometric, do you know what is stoichiometric air fuel ratio? It is not standard. It is the chemically correct air fuel ratio. Like suppose approximately composition of the petrol. Do you know what is the, how much carbon, what is the formula of the petrol? Because my all design start from here. It is approximately C8H18, approximately, not very accurately, but it is sufficient to calculate. If you, what you can do, I can give you exercise also, because if anybody is keen and understand the fundamentals, you just write down the C8H18 and react it with the oxygen and make it a equation, balanced equation. And from here, you can find out what is the amount of air you need to burn 1 mole of fuel, how much mole of air is required, or 1 kg air to burn 1 kg of fuel, how much air is required. This is the backbone of the engines. If you don't know this, like it is a foundation, so you can't erect the building. So C8H18 plus oxygen, then again in oxygen, when you are burning the oxygen, I am finding out the air fuel ratio, not oxygen. So, and what is the percentage of oxygen in the air? 20. Anybody else? 21. Anybody else? 26. So it means more precisely it is around 20.9%, approximately 21. You can say it is the right answer. So 21% oxygen is there. So what you have to do when you are calculating the from that equation, so you have to multiply with this factor to calculate find out the air. On internet also it is easy. So my request is please try to do this exercise. Okay. Now I have, suppose 1 gram of fuel I have injected. So how much air I need? 14.7. This is chemically correct, what is known as, based on the equation which I have given you, calculated. So we call it stoichiometric air fuel ratio. Actually in the engine it may be slightly more or it may be slightly less. I can provide slightly more, I can provide slightly less, or I can provide stoichiometric also. That depends upon the engine requirement. But the variation is little bit, not 50% or like that. It may be plus minus 10% you can provide, depending upon whether you need more power, whether you need more efficiency, whether you need lower emissions. It depends upon what you are looking for. Appropriate air fuel ratio, we have discussed this. Now it is clear to you. What is the air fuel ratio? What is the stoichiometric air fuel ratio? For petrol, it is 14.7. And to calculate this, you can use the equation C8H18 plus oxygen. And oxygen के bracket में आप डाल सकते हो उसका correction factor to calculate the amount of air. Now, air and fuel ये है mixed, and it is now entering into the combustion chamber, right? What you need now? Very good. Now you need spark. And spark intensity is important. Now there are two things now. One is what should be the intensity of the spark? If spark is very weak, it may not be able to ignite the mixture. If the spark is too strong, it may burn the spark plug, life may be less, or it consume unnecessarily energy. So another important point is, one is the appropriate intensity of the spark. And what is that? What else? Suppose I have given a spark of enough energy. What is another parameter which is important? Timing. What time I should create a spark? If I am creating before the TDC, 50 degree before TDC, it may not ignite. 100 degree before TDC, it may not ignite. So I have to ignite it very close to TDC, maybe 10 degree or 12 degree before TDC. So it means mixture preparation, we have discussed proper intensity of spark at appropriate time. So now I summarize. So air and fuel is important. Air fuel ratio is important. Then appropriate intensity of the spark at appropriate time. If I want to manage all these things, for that I need engine management system. Now, when you will calculate that, you can just see the composition by volume of the air is 20.95 oxygen, but you treat as a 21% also, absolutely no problem. And nitrogen is around 78%, the rest are some inert gases, so that can be ignored, right? Okay, one terminology I want to discuss with you, that is, like we talk about 100 cc and all that. You might have also heard about the volumetric efficiency of the engine, right? Can someone define what is the volumetric efficiency? What is the volumetric efficiency?
Displaced volume upon volume of air.
Like displaced volume is, like suppose we are, let me give you an engine. Suppose you consider a Alto engine, which is 800 cc engine, right? Or any engine which you know, maybe if you have bike 100 cc, 150 cc engine. Suppose it is 150 cc bike. So 150 cc is the displacement volume. So what it means, what do you mean by volumetric efficiency then? 150 cc, when it will, piston will move, it will displace 150 cc. Whatever diameter is the pi d square by 4 into stroke length, right? Then what is the volumetric efficiency? Because piston will displace that much only.
Total volume on clearance.
No, that is the compression ratio, like something, it is not even a compression ratio, but that is not the volumetric efficiency. Displacement will remain same, no? Or it will change. The piston is moving from the top to bottom. So displaced air will remain same. So what is volumetric efficiency? Because it is very important. When I go in the engine management system, this is very important parameter. So this is like when my piston is moving from top dead center to bottom dead center, it is sucking some amount of air. The volume remain same, mind it. The volume of the air will remain same, but if you have a throttle or something in the intake, like you use in the carburetor and all that, so the density of the air will reduce. So mass of the air which is sucked in, that will reduce. So it is the mass of air which the engine can actually suck in due to the displaced volume. Okay. Actual mass of the air which is sucking and the engine which it can suck theoretically. It is the mass of the air. You get me now? So whenever you are using any throttling, it is reducing the density of the air. So less air will come. Volume will come same, but it is a mass. So when we are talking about the volumetric efficiency, most of the time, all the engineers and even students, they confuse with the volume of the air. They think it is the volume of the air, actual volume to the displaced volume. So it is, first thing is, it is not the volume. What is this? Mass. Is it clear to you?
So our throttling will change the mass.
When you are having the throttle, what it is doing? It is providing the restriction to the air. If suppose this is the passage, I have blocked it completely, or only I have opened only 5%. It will allow very less air to go. Why? Because it is stopping there, and only when through that hole it will go, it will, by reducing the density of the air. Are you getting me? Like when I am blocking it, I can block it 100% also. Maybe 1% leakage, so very little air will go. When I am making the full throttle, when you are accelerating the car, what you are doing? You are opening the throttle full. So volume is same in the displaced volume, but it is the quantity, it is the mass of the air which is increased. And 99.9% students and engineers, they make mistake here. So even if you have learned today this, your day is successful. Okay, next. Another important thing is density of the air. You know, it is dependent on the temperature and atmospheric pressure also, right?
Yeah.
If in summer I may take my vehicle to Rajasthan, the temperature may be 45 degrees Celsius. Your engine is same 150cc engine. At 47, and another bike I have taken to Simla, their temperature may be 10 degrees Celsius. Okay. If the temperature is lowering, we can say in the winter. In the winter, temperature may be 5, 6, 7 degrees. Even in Chandigarh, maybe suppose 10 degrees Celsius. And one is you are in the peak summer noon time. Your same engine is operating. So in winter, definitely the engine will take more. In winter, engine will take more air in winter or in summer? In winter. Because the mass of the air will be more. Why mass of the air will be more? Volume is the same, 150cc. Mass is into density. Density will, bolo yaar, density will be more. चलो मेरे को ये बताओ. Suppose today, what is the temperature? 16 degree. What will be the approximately density of the air? 1.2. So if the temperature is low, 0 degrees Celsius, then density will be increased. So mass of air will increase. So in winter, the engine can develop more power. So, and your air fuel ratio will also change. and you have to, or if you want to maintain the air fuel ratio, you have to change the quantity of the fuel. And depend all this effect of the weather, temperature. Then you talk about you may go to Missouri also, maybe at the hills. Your vehicle may go to Kashmir also. So at the high altitude, the pressure is decreasing. If pressure will decrease, what it means? Density will decrease. Density of the air will decrease, means mass of the air which is sucking by the engine is decreasing. So you have to adjust that for the air fuel ratio. Now, till now, whatever we have discussed, is it clear to you? Right. So if all these now earlier I was using a carburetor. So carburetor cannot compensate for all these variations. You understand? If temperature is high, carburetor jet, because jet is fixed, it will give the same quantity of the fuel. Another important thing I am going to tell you. This is the fuel. That important thing is, suppose today you have purchased a bike. After 5,000 kilometers, your bike is running on the roads. It may be running on the dirty roads also. And in the air, dust is there. So you know we are using a air filter.
Excuse me, sir.
Yes, please.
Sir, can you please explain volumetric efficiency?
Volumetric efficiency is the mass of the air which engine is taking actually divided by mass of the air which engine can take theoretically. So it is the mass of the actual air divided by mass of the theoretical air which the engine is taking. Okay. Now, if my air filter is blocked with the dust, what will happen? It will restrict the air to going to the engine. When the engine was new, a filter was new, suppose I am taking an example. Engine was taking around 50 milligram of air per stroke. I am giving you actual figure. Okay, 50 milligram of air is sucked in by the engine when the filter is brand new. After 5,000 kilometers, due to the dust, some restriction is created. The amount of air the engine will take now will be less or more? Less. So instead of 50 gram, it may be 48 milligram. Instead of 50 milligram, it may be 48 milligram. So it is reduced by 2 milligram. If the amount of air is reduced, but if there is a carburetor, the fuel will be same. What will happen? Mixture will become rich. Mixture will become rich means your fuel economy will be decrease. Is it clear? So like that, there are many parameters. After some time, you have covered a bike of 60,000 kilometers. Your suction power, your vacuum, due to the wear and tear, will reduce. Amount of air taken in by the engine will reduce because it is the piston effect. Piston and piston is water, it will not suck. The vacuum created by the engine will reduce, or you can say compression ratio will slightly reduce. So air quantity. So all these variables cannot be taken care by the carburetor. So that's why.
What in case of air filters containing oil in it?
Even if air filter is having the oil dipped, there is a mesh of iron fibers. So there even you find a lot of dust is there. So pressure drop will increase whatever the air filter may be, whether it is the paper type or it is the oil filter, after some time. The variation in pressure drop may be different depending upon the design of the engine, because there is a very important parameters in the air cleaner design, that is the dust holding capacity. Suppose whatever if you design this bottle, so this can hold certain amount of water. Are you getting me?
Yes.
Now I have two bottles. So these two bottles, they have a different capacity, right? This can hold maybe 200, this may hold 400. Similarly, I am designing a air cleaner. When I am using in the vehicle, what should be the dust holding capacity? You can note down this terminology. That, like, this bottle can hold 200 ml of water. Similarly, all air cleaner are designed, their abbreviation is dust holding capacity. Whether they can hold 10 gram of dust, 20 gram of dust, 40 gram of dust, that is, you can decide at the design stage. For example, for a motorcycle, and how I decide that, I keep on increasing the dust. After some time, the pressure drop will increase. So there is a limit. Suppose earlier the pressure drop is only 2 kilopascal. So some certain amount of air was going 50 milligram. When the dust is 10 milligram, the pressure drop across the air filter is increased from 2 kilopascal to 4 kilopascal. And if I increase the pressure further, 4 kilopascal to 5 kilopascal, my engine will not perform well. So I limit that. So in my design, I say, okay, the amount of dust the air cleaner or air filter can accumulate before reaching the terminating pressure drop. And that terminating pressure drop is what you decide. The delta P should not be more than 2 or 3, depending upon the designer. Is it clear? So any filter, when it's, even this is the same thing with the fuel filter also. When you are passing the fuel filter also, after some time, 10,000 kilometer, 20,000 kilometer, you are changing it. Why you are changing? Because the dust is accumulated, and when the lot of dust is accumulated, it causes the pressure drop. And we decide what is the terminating pressure drop. Means the pressure will increase gradually, but there is a certain value after which the engine will start deteriorating significantly. And there I say, okay, now change the filter. Clear? So there is an abbreviation, dust holding capacity of the air cleaner, air cleaner efficiency, generally that is around 99-98%, and initial pressure drop and terminating pressure drop. These are the two important parameters for the air cleaner, which decide the dust holding capacity and life of the air cleaner.
How actually this pressure drop is, what is this pressure drop exactly?
What is the question?
So where is this pressure drop occurring? On filter side or piston side?
The filter side, across the filter. Suppose I have pipe something and you block that pipe and you try to suck. Can you suck then? If I use a very thin paper on the tube, you may, or a simple cloth of cotton, you may be able to suck through the pores. But if I increase that thickness or I put some dirt, it is difficult to suck. So the pressure drop is increasing across the media, across the air filter, across that element. Is it clear? Air filter we have discussed already.
What if we add extra snorkel to the cars? So what can the air fuel ratio, can it be improved the efficiency, or the power should be increased with it?
No, that snorkel or cyclone we are adding in off-road vehicles or in the trucks where the dust is more. So if you use only air cleaner, they will choke very quickly. Suppose in a tractor or in truck, you are going in the dirty area or in the mines area or even some off-road vehicle or even trucks and buses where you need more dust is coming. So we use one is the cyclone. What cyclone do? Due to they create a swirl motion, and in that motion air particle can move in and they change the direction suddenly. So air can move and change the direction, but dust cannot do that. So dust is accumulated there only. So dust is separated out by the swirling motion of the air without the media, without the air filter. Suppose your dust in the air is, so the heavy particle maybe of 200 micron, the bigger particle, they will separate it there only. And very, very fine particle which air can carry, they are going to the air cleaner, and those particles are, even we are having that what are the technique to use or to separate the dust. But that is important, what is the dust size. Suppose in the home you are using आटा छानने के लिए जो छलनी होती है, so that depend on the pore size. If that is very thick, lot of that dust may go. If it is fine, though it is a segregation. So in air cleaner, the size of the particle is very, very whether you are doing 20 micron, 40 micron or 80 micron. So the snorkel system or this cyclone system are to separate the heavy particles of the dust from the air. So it is done in two zones. One is there, and then actual filter will come, so that your actual filter life will be more. Are you getting me? And that you can remove and you can clean it. Like our Omni vehicle, this and all this little bit commercial vehicle, they have this snorkel and cyclone system. Car generally don't have, because car generally it is supposed they are running in the cities only and on the roads, so they are more, they don't need. So experiments show that your dust holding capacity, I can give you a typical example of Alto 800cc. The dust holding capacity is around 100 gram of dust, and you can change this air cleaner, you can clean it after 10,000 kilometers, but we advise at every 5,000 kilometers, because it depends upon the environmental condition also. Suppose somebody is running the car in Rajasthan where dust is more, somebody is running in Chandigarh, the dust may be comparatively less. So it depends upon the environment, but generally it should be cleaned after 5,000 kilometers. Even very advanced car, आपके यहाँ पे board है क्या? Very advanced car, what they do, across the air cleaner element, I am putting the pressure sensor. I am measuring the delta P there. In the new car, suppose the delta P may be say 95 kilopascal, or delta P is 5 kilopascal, between the atmosphere and that 5 kilopascal. When the delta P is increased, then I glow a light, because I have put a pressure sensor, and that will indicate now clean the air cleaner, because otherwise it is difficult to you whether it is, what is the pressure drop across that. So but that require additional cost. You can, so you can put the pressure differential sensors, and you can put that light in the vehicle, so it will glow when the pressure drop is increased to the terminating pressure drop. But all these things you can do when you have the fundamentals. Even suppose before coming, I can assure you, like if you will listen the talk carefully, your neuron structure, your brain structure will change after every hour. When I will leave the class, your neuron structure, your brain will be in a different synaptic weight. That I can assure you. And you can be more creative, because when my fundamentals are clear, my interest is created. And here in 1 day or 3 hours talk, we cannot teach you each and everything, but we can create the fire in you to learn the things. And the fire is created when I am able to create the interest. And interest is created when you are able to understand. But we are escaping from the things to learn when we don't understand it very fundamentally. So interesting. Like you see, this is a bit like you can think, okay, can I make a logic in the filter, and it is good. Like I can put in my vehicle, okay, when it give the light, I should change the air filter, and then we say, okay, now you don't change the air filter when the light comes. You clean the air filter and reuse it. Then you can do it 3 times. After that, its dust holding capacity will be totally the paper. So that's why it is advised in first service you can clean the air filter, in second also, in third also, but at the 4th time you replace that. Now you understand how important is air cleaner. I tell you, if you want to improve the fuel economy of your car, of your friend's car, you can advise him. These are the practical. They say, yeah, he's a good engineer, you know the facts. So we should be a practical engineer, not the theoretical engineer only. We should be capable to correlate the theoretical aspect and the practical aspect. We should consider the implementation point of view of that. And even now you can think, what type of paper I should use for the air cleaner? Are you getting me? There are different type of paper, non-woven type, woven type, and what should be the pore size of that paper? Even that is very important. जैसे मैंने बताया ना छलनी के लिए पेपर भी there is a pores, and if the pore size is supposed 20 micron, it means the dust of size of less than 20 micron will carry with the air. No. So that is also very important aspect. Even each and every component of the engine management system and engine is involving in a big technology. Even what you see, very simple air cleaner. Many research are going, many patents are going. Number one, there is expertise available only who do the paper development. What type of paper I should use? Now, they are working on the nanofiber. So that I told you the pore size. Because if I have the nanofiber, I can increase the dust holding capacity without increasing the pressure drop. That is what nanotechnology means in that. So paper media is one. Then what is the shape of the air cleaner? There are many shapes: split type, round type, square type, rectangle type. That again are number of pleats. Now there is an area because I have to increase the surface area. How I can increase the surface area of the air cleaner so that it can accumulate more dust with lesser pressure drop. Okay, here you can just see maybe this is the air is coming from here, right? So this is the sort of a, you can assume sort of a air filter type like here. That air should be clean and it is going. Anyway, this is giving the stoichiometric air filter for different fuel. Gasoline, CN H1.8N. If you are assuming 8, then you can just do diesel is like this. Propane, methane is CH4, methane is CNG. In after lunch class lecture, we will cover alternate fuels. In that, we will cover CNG and LP, methane and propane also. Hydrogen H2. Now, this is the only fuel which don't have the carbon. So, recently we have done a project which is for a hydrogen engine. So, there are 2 engines which we have converted into hydrogen. So, they are running now. And the beauty is, because there is no C, there is no CO2. There is no unburnt hydrocarbon. There is no CO emissions. So CO is not there, HC is not there, and CO2 is not there. So it is almost emissions free. Can we say? More or less, but there is a problem. Because nitrogen is in the air, it reacts with the oxygen and we produce the nitric oxide. In other engines also we are producing nitric oxide. So nitric oxide is produced. So that we have to find a technique how to reduce the nitric oxide or NOx. Because there are 3 pollutants which we have to control: CO, HC and NOx. Are you feeling your neurons are activating? So just involve in this. Next is, you see, now the question arises, Why I should change the air fuel ratio? Now let me understand the automotive engine and even genset engine. That first we talk about the automotive engines. When you are driving a car or bike, you see, first you start it. It is running in idling. Then you put first gear, accelerating. Then second gear. Then deaccelerating. Somebody comes again applying brake. So automotive engine is operating under varying load and speed conditions, right? If there is one speed engine, you can optimize the air fuel ratio and it will run at that RPM only. Genset engine is relatively easier to tune it, calibrate it. But automobile engine is acceleration, deacceleration. Sometimes you are sitting alone, sometimes your family is sitting, load changes, speed changes. You are running at 60 kilometers, you may run at 100 kilometers, you may run at 80 kilometers, you may run at 30 kilometers. You are going to Simla, again load changes. So it is a very dynamic conditions. And what is the effect of all these things? Let me have a look on that. See, if I need, this is the power. Now, if I need more power, for that I have to make the air fuel ratio slightly rich. I have to give slightly more fuel as compared to the air. I will get the more power. But it doesn't mean if I make more fuel, more and more, power will increase. It is up to a certain level, and that level is approximately 12.5 ke aspas. At a 12.5 air fuel ratio, I will get a maximum power. But at what cost? My fuel economy will increase. This lower curve is fuel consumption curve. Now suppose you say, sir, I am bothered about fuel consumption. My bike should give maximum average. It should run in 1 liter of petrol 100 kilometers.
Hello. Hello.
You have to tune your car or bike where you get maximum or lower fuel consumption. Here. So what we can do, so this is what you are getting the minimum fuel consumption. So minimum fuel consumption point is at 16 and power point is at 12.5. Yes, please.
Hello.
Yeah, yes, please.
Yes, sir, there is a small query from my side. How do the humidity affects the suction process of the air?
Clearly.
Hello.
My coach.
Hello.
Yes, please.
Hello.
आप बोलो ना।
Hello. Sir, can you hear me? Hello.
आपने ऐसे, so what we can do, you can ask everybody, maybe we can keep 10 minutes for question answer, and at that time they can ask. वो डिस्टर्बेंस आ रही है ना उससे. So it means, it is very interesting to understand. So if I need more power, I need a air fuel ratio of around 12.5 or 12.4 approximately. So you don't catch me, okay sir, आपने 12.5 बताया था. So it is approximately, means we can say definitely we need slightly richer mixture, more fuel. The point may be different. It depends upon the engine also. It depends upon the fuel quality also. But if I want better fuel economy, air fuel ratio is, I need around 16. Now, it means different mixture strength are required under different operating conditions. So when I am calibrating the car, I know when I need power. Suppose I am accelerating, I need power. When I'm going at a steady speed, so I can use the linear mixture also. So this is what is a calibration means. You have to do it. But here the idea of this is that different type of air and fuel ratio are required under different operating conditions. Do you agree with me?
Yes, sir.
Okay, so you please remember this. Now, one slide we have discussed with the power and fuel consumption. Okay, so when you want more power, you have to sacrifice the fuel economy. When you have get the more fuel economy, you have sacrificed the power. Okay, now let's see next. If you see this is the flame speed. You see the flame speed is maximum at a stoichiometric, little than richer than the stoichiometric. So here the flame speed is around maximum around 14:1. It means your combustion will be much better when you operate in this range. Okay, now in next slide we go to the effect of the air fuel ratio on the this. I am combining all flame temperature, power output and fuel consumption, right? Now let me see on the emissions. It is again a very interesting. Now I have to control all the emissions. You want to control CO. You tell me what are the pollutants you are controlling in the engine? Carbon monoxide, nitric oxide, hydrocarbon. Very good. So we are controlling 3 emissions. Now 4th emissions regulation is also coming. CO2 also we have to control in future. But at this moment we are controlling all these 3. Now look at this, how the air fuel ratio is affecting the all these 3 emissions. Now first you see this bell type of curve. It means this is the NOx. NOx is maximum when your air fuel ratio is very close to stoichiometric. And why NOx is maximum? Because NOx is the phenomena which is directly proportional to the temperature of the combustion chamber. If the temperature will be more, NOx will be more. NOx formation take place at around 1200 degrees Celsius. When the temperature inside the combustion chamber is around 1200 degrees Celsius, at that time nitrogen can react with the oxygen, otherwise it will not react. So it should be 1200 or above the 1200. Okay.
Sir, if the air will be less at the combustion time, what will the effect on carbon monoxide?
What is the question?
If the air is less at the time of combustion.
Air is less.
At the time of combustion.
हाँ, तो CO will increase. वो डिस्कस कर रहे हैं अभी मैंने पहले नॉक्स का बताया आपको. नॉक्स से कोई रिलेटेड क्वेश्चन है तो आप पूछ सकते हैं. वो CO का तो मैं क्वेश्चन बताऊं. अब ये देखिए आपका CO का कर्व है. ये CO में क्या है, यदि यहां पे मैं सपोज हियर if I am making the mixture rich, more fuel, CO will increase. So this is the point as stoichiometric. If I am increasing the fuel, yani ke if I am increasing the air fuel ratio, CO is increasing. In other words, you can also say if I am reducing the fuel quantity, I am making the mixture leaner and leaner. You see the CO will decreasing. So if I am getting the better fuel economy, I have to make the mixture lean, means CO will also decrease. Now come to the hydrocarbons. Hydrocarbon is also increasing when the mixture is rich. It will come down and it is minimum around stoichiometric.
Sir, carbon monoxide emission that will depend on temperature or not?
No. They are function of air fuel ratio. When hydrocarbon is HC emissions are reduced when I am making the mixture very close to stoichiometric. And if I am making it leaner, again it will increase. It means if I want to reduce the CO, my requirement is different. If I want to reduce the HC, my requirement is different. If I want to reduce the NOx, आप समझ रहे हो ना the complications. If NOx I want to try to reduce, my CO and HC will increase. So to balance all these things is a very difficult task. It means what I have to do, I have to optimize the power, I have to optimize the fuel consumption, I have to optimize the CO emissions, I have to optimize the hydrocarbon emissions, and I have to optimize the NOx also. And at the same time, I have to optimize the drivability also. So, and each and other parameter, they are contradicting each other. You see, I can reduce the CO, but HC say I will increase. I can reduce the NOx. So, but at certain cost. So you have to balance out all these things. And this is the art of calibration. Right? I think we have a break now. If there is any questions, then we can, somebody was asking if you can just check if some. हाँ उनका एक बार पूछ लो आप क्या क्वेरी है.
अरे स्पीकर नहीं चल रहा है.
लैपटॉप के पास से बोल दे.
हेलो. हेलो.
कैमरे के पास
हेलो.
Hello. Yes, please. Any question, please?
Hello.
Yes.
Hello.
Yes, please.
Sir, how humidity affects in the air cleaning?
Relative humidity, like if it is more, then air cleaner life will reduce. Any other question? Okay, we can proceed. There are so now let me summarize. Optimum air fuel ratio is different for peak power. Optimum air fuel ratio is different for good fuel economy. Optimum air fuel ratio is different for minimum CO. Optimum air fuel ratio is different for hydrocarbon emissions. Optimum air fuel ratio is different for minimum NOx. So all are conflicting each other. To manage all these things, the carburetor, which was till now we are using, is not capable to meet all these requirements. So hence we have changed the technology from carburetor to electronic fuel injection system, which is our what we are talking about. So this is sort of a history now. This is the history already in cars. No car is fitted now with the carburetor, but most of your motorcycle and three-wheeler, they are fitted with the carburetor. But to update you, do you know by 2020 all the motorcycle has to change to EFI? In the BS6, which is we are going to implement in 2020, there will be no bike which is running on the carburetor technology. And even now, there are certain bikes, they have started using the electronic fuel injection system, or you can call it engine management system. But Euro 6 cannot be met by using the carburetor technology. So the topic which we have taken today, it is the emerging technology, futuristic technology for all the two-wheelers and three-wheeler, which is already implemented in the passenger cars. So it is highly mandatory because all your mechanical, all your technician, all your engineers, your bike will go on the servicing also. They have to change their attitude, and it is the right time to start with that. So my request is, even suppose your students, whenever, wherever related to EFI, most of the mechanic, they can repair the bike. That will not be in future. Like car, mechanical, like wheels, brake, they may do, but engine related parameters they cannot touch even. So it is a big change. So my sincere brother, like we can, because when I'm looking at the courses sometimes, last time I got some courses from some universities, I was surprised. The syllabus which is covered in the syllabus of your engine courses or mechanical engineer, the technologies are totally obsoleted. They are meaningless for the industry. If today, suppose somebody want to join the Honda motorcycle, so they need an engineer who can work on the EFI system. They need an engineer who know the emerging aspect of engine technology. So my request is at the same time to all the teachers, because this is the right forum, that number one, you can request to revise your syllabus also. I'm not saying, like suppose the carburetor is covering, say, to reduce it maybe from existing 20% to 2% and replace that with the latest technology. All the, even the experimental work of the EFI system. So that is the purpose of this. So now by this time, we understand the fundamentals, fundamental requirement of the engine, about volumetric efficiency, about the intake system, about the importance of the air-fuel ratio, and because we know the carburetor was not capable to meet all the varying requirement of air and fuel under the different operating conditions of load and speeds. Hence, we have to change, we have to replace the carburetor to the electronic fuel injection system. Please. The ECU. What are the actuators? Where we have to mount, and what are the principles and design aspect of each and every sensor, and why we need those sensors. Another aspect, the EFI for car is totally different. For motorcycle, it will be slightly different, because the motorcycle cost is, say, around 50,000 rupees. The car average cost may be 6 lakhs rupees. So if I am developing a EFI system for a car, and if the cost is 30,000 rupees, car can absorb that cost. But in a bike which costs 40,000 rupees, if I make a EFI system of 30,000 rupees, nobody will buy that. So the big challenge which will come across, that is I have to give a very advanced technology at a very low cost. That is again a challenge, where innovation has to take a very important role. So some limitations of carburetor, again I can just summarize. As we have discussed, that engine has to operate under varying load and speed conditions. Carburetor is not suitable. poor atomization of the fuel because the pressure is very low, it is atmospheric. The atomization of the fuel is poor. If atomization of the fuel is poor, mixing will be poor. If mixing is poor, combustion will be poor. If combustion is poor, your performance, your fuel economy, your emissions will be poor. And just a typical example. A Maruti 800cc engines need only 3.3, around precisely 2.98 milligram of fuel per cycle per cylinder. If it is 2.8, it has gone out of the limit. If it is 3.2 milligram, again, your emissions or your performance or your power will change. So to control this quantity very precisely under all dynamic conditions, it is not possible for a carburetor. I can tune a carburetor. Suppose I can tune a carburetor at 50 km of speed, constant RPM 2000, it can give this quantity. But whenever I change the speed and load, carburetor cannot handle this dynamic response. And that is the limitations of the carburetor. Beside this, I have already told you, in multi-cylinder engine, not in single cylinder, because carburetor is at the center, I have to give the fuel to all the cylinder. The mixture distribution is not uniform. Cylinder number 1 may get different, 2 may get different, 3 may get different because of the length. Complete fuel cutoff during deceleration is not possible. This is a very important aspect which I will discuss with you. When you are running at a speed of 90 km or 80 km per hour speed and you want to retard the engine at that time because you want to reduce the power and your carburetor is still giving the fuel, I don't need that. What I want that, I may be applying brake, so I should develop a strategy. I can cut off the fuel during the acceleration period. What will happen? My fuel economy will improve, my braking effort will be low, and my emissions will be at that time will be 0. Last week we were testing a 3-wheeler because we have converted a 3-wheeler on a electronic fuel injection system. That vehicle is on road, has covered around a few thousand kilometers, but we are calibrating that, we are checking on the chassis dynamometer, and it is observed our emissions were very low. We have seen that when you are using the carburetor during deceleration, fuel is still coming. At that time, during IDC, during Indian driving cycle, when you check on the chassis dynamometer, that emissions count a lot, around 30%. By reducing, by cutting off this fuel supply, you can cut off the, because there is no fuel, no combustion, no emissions. And because you want to retard the speed, but again the important strategy is till how long I should cut off the fuel. Suppose the engine RPM are 5000. Now this is very important control strategy and logic. From 5000, speed will come to 4000, 3000, 2500, 2000. Then I have to restart the fuel so that the driver should not feel the jerk. He should know. He should not be aware about any jerk. So that is a tuning, that is a calibration. And even that is a strategy and logic which we have to develop and put in the software. So can we close now for a tea break? Huh? Because it is already 11:45.
We at 12. Break for 15 minutes.
15 minutes. I mean, something you feel that you have learned something, because the idea is that whatever we discuss here, your doubts should be clear completely. If your doubts are clear, you can communicate the same thing to your students also. And if it is communicated to the students, that will be helpful to the industry also and for the students also. So with this, I think we have a break of 15 minutes and we will assemble it here again around 12 o'clock. And we will take you on the journey of electronic fuel injection system, which is the future of motorcycle and 3-wheelers. Okay. ये लैपटॉप वगैरह यहीं पे ही रहेंगे हमारे, ठीक है मोनिका।
ਹੁਣ ਧਿਆਨ ਨਾਲ ਬੋਲਿਓ ਵੀ ਕਾਕਾ, ਫਿਰ ਕਹੋਗੇ ਤਾਂ ਵੱਲ ਜਾਂਦਾ।
ਵਾਹਿਗੁਰੂ ਜੀ ਕਾ ਖਾਲਸਾ,
ਇਹ ਜੋ
ਸ੍ਰੀ ਵਾਹਿਗੁਰੂ ਜੀ ਕੀ ਫਤਿਹ।
ਕਿਹੜਾ ਤਾਂ ਵੱਲ ਨੂੰ ਜਾਂਦਾ।
ਕਿਹੜਾ ਹੈਗਾ ਤਾਂ ਵੱਲ ਨੂੰ ਜਾਂਦਾ।
ਨਹੀਂ ਕੀਤਾ ਸਰ ਆਪਣਾ।
ਆਪਣਾ ਮੂਡ ਕਰ ਦਿੰਦੇ ਆ।
ਸਹੀ ਗੱਲ ਹੈ।
Use apps. Student
So good afternoon. So I think we will continue by keeping in mind the background of fundamental requirement of the engines. What is the engine? What is the basic need of the engines? We have discussed it is the amount of air, fuel. Then we have discussed what is stoichiometric air fuel ratio. Then we have discussed what are the effect of the air fuel ratio on power. What is the effect of air fuel ratio on fuel consumption? What is the effect of air fuel ratio on
Yeah, sir.
emissions?
Sir, actually, Institute. Okay.
So it means we can conclude that air fuel ratio has a significant effect on engine performance, like fuel consumption and power. Similarly, it has the effect on the combustion characteristics like flame speed, combustion temperature, and combustion pressure. And then we know it has the significant effect on the exhaust gas emissions like hydrocarbon and NOx emissions, right? And we have also seen that throttle body is not able to, carburetor is not able to meet all these varying requirement of different air fuel ratio and ignition timing under different operating conditions.
Sir,
Okay, now little bit we have discussed about the air fuel ratio. Another important point was about the ignition energy. We have discussed, right? Let me brief you about the ignition system also. Actually, what happened earlier, what we are using, there is a contact breaker point. You know that ignition energy required during the spark is around 20,000 volts to 30,000 volts. Okay, and that voltage, because your battery source is at 12 volt, so that voltage is converted into that 20,000 volts by a ignition coil, right? And in that case, there is a primary winding, there is a secondary winding. In the primary winding, the current flows around approximately 2 ampere. So 2 ampere current is flowing, and then with that current, number of coils, number of turns on the coils are different on the primary and secondary. Wire size is different and number of turns are different. So which is helping in producing the high voltage, lower current, because energy cannot be created nor be destroyed. So if voltage is 12, current is 2 ampere, so current will reduce in the secondary and voltage will be very high, because you need a high voltage to jump across the electrode. So you need to create the spark. Now, what is happening? So next time, Pena, we can make here more. Sometime you make. So what is happening? Like if when I'm making the contact breaking, open and close. So suppose 2 ampere current flow through this contact, and when I am closing it, the current flows. When I am breaking it, the current stops. So when this is happening, when it is opening, the spark take place here, and the pitting take place. इसलिए आपने देखो पहले they were just with the emery paper they are making this and they are making this contact. Now to avoid that, we have introduced electronic ignition system, which are known as capacitor discharge ignition system or transistorized ignition system. So that is electronically controlled. So that will be also the part of the engine management system. So we have to control the appropriate quantity of fuel at appropriate time. At the same time, we have to control the ignition timing also and ignition energy also. These are the emissions. Just to give you a background, if you see, earlier we have the Bharat stage 1. This was introduced.
Sometimes we use a condenser in battery ignition system.
In battery
ignition system.
Mm-hmm.
After the ignition coil, we use condenser also.
Mm-hmm.
What is the purpose of that condenser?
Condenser to avoid that spark, so that it absorbs the spike of that spark. That is the purpose of that condenser. When it is opening and closing, it creates spark, so that during that time it can absorb the voltage and it store that energy, and when it require it, give that energy. So we are putting a condenser across the breaker point. BS1 is Bharat stage 1 emissions norms. We can make it Euro 1 also. And these norms I am just giving you for the cars, because like that there are slightly different norms, but you have to understand the philosophy of the emission norms. So we have the BS1. It was introduced in around 98. Then we have the Bharat stage 2. It was introduced in 2000. Then BS3 was introduced in 2005. Then BS4 was introduced in 2010 in cars. Okay. BS4 in motorcycle is introduced in 2017. In March or 1st April it will be introduced. BS4 in motorcycle and three-wheeler. And in 2020, we are introducing the BS6. So if you look at when we are gradually increasing from BS1 to BS4 and BS6, your emission norms are CO is like earlier it was 2.7, now it comes to 1. And in BS6 again it is reduced by 50%, maybe 0.5. HC is also reduced, so NOx is also reduced. So there is a significant reduction in the regulation to control the emissions. And why we are controlling the emissions, I think you all can understand now. Most of the newly born child in metropolitan city, they are facing the asthmatic problem. They are breathing related problem because of the air pollution. So air pollution is at alarming level. Recently, you might have seen in Delhi, your emissions are 7 to 8 times higher than the safe limit. So we are living in a gas chamber. So what I will do with that technology, which is killing my next generation.
In Beijing, it's spending one day in Beijing is equivalent to smoking 21 cigarettes.
Cigarette. So your life is reduced. So it is a sort of a slow murder. Because immediately it is not killing you, but it is killing you slowly. I am surprised because whenever I visit any family in NCR, there are small kids, 3 months, 5 months, 6 months, 1 year, they cannot breathe. Every mother has to give puff to them, inhaler. See, and even that is harmful for them. Is the technology
is for that purpose? Certainly no. So we have to balance out the things. So that's why now we are going for partial zero emissions, and BS6 is in that direction. Even due to all these things, actually we were supposed to go for BS5, but Supreme Court, they say no, because emission is at alarming level. They say we have to jump directly to BS6 so that we can save this our planet. We can save the humanity on this ground. Otherwise, technology will be there. There will be no human being to take that technology, to use that technology. If the emissions and pollution is not controlled, the stage may be expected in 2040. Either you breathe or you drive. It will be so alarming. So we are expecting a lot from young engineers like you, because you may be there at that time, and you can train your students, and you can really focus during your talk that pollution control is a prerequisite for survival of the next generation. And the technology which we are talking today, that is a one step ahead in curbing that emissions. Now, in future engines, I can do that. But again, the question arises, what is the existing vehicles? What about the existing engines? So for that also, government is making certain rules that you cannot register your vehicle after 15 years. You have to discard that vehicle, or after 10 years. Now I think it is around 15 years and they want to reduce it to 10 years. You cannot use the vehicle for more than 10 years. Yes, gentlemen. Now we really start with the multi-point fuel injection system or electronic fuel injection system. Now you can categorize this system into 4 subcategories: air intake system, fuel delivery system, sensors, and engine control module, which is the brain of the electronic fuel injection system. If you look at the air cleaner, as I was discussing you, this is sort of a air cleaner element, and this is paper type. And you know, all this pleating white has been done to increase the surface area so that you can hold more and more dust. And there is a mesh also. This mesh avoids the damage of that paper, so that when the air is coming with pressure and high velocity, it should not damage the pleats. So this is a air cleaner, and from here the air is passing to the intake manifold through the throttle body. This is that throttle valve which I was talking about. So when it is opening, it allows more air. When now it is closed, so it allows very little air, maybe 10%, and this position is equivalent to at idling. So as we have discussed, air filter, it prevents the dust particle from being drawn into the engine, as a result to help reduce the internal wear of the engine. If you start an engine without air cleaner, can you imagine what is the life?
Okay.
Engine life will be reduced to only few hours as compared to 1,000 hours. The life may be completed in even only in 1 hour. It will be totally damaged. So from 1 hour, nobody wants that his engine is killed in 1 hour. So this is a very important component, and don't take it lightly. It is, whenever, many times, so that audience and participant can remember all these things. Air filter, you can assume like your nose. You see there are small hairs in your nose, and some liquid is also there. So that actually trap the dust particle. So that's why I'm saying always you can inspire from the nature.
and intake system design of the engine, I tell you a real story. We were working earlier, you know, there are only two valves in engine, one intake valve and one exhaust valve. So in intake, through intake we are inhaling, through exhaust we are exhaling. Now, because as I have discussed, air is the most important parameter, not fuel. It is the air which decide the power, which decide everything. We thought that how we can increase the volumetric efficiency. So there was one passage. So idea was we can make it two valve intake. So instead of one, we have two. We can draw more air to the engine. And two exhaust. So it is a 4-valve technology. Okay. And first time we have introduced this in Maruti also in India. But there are other engines also, Honda and all that. They are 4-valve engines. But most of the motorcycle engines are two valves, one intake, one exhaust. So anyway, for the sake, then we started the designing, because when you have that two intake valves, so through the intake manifold, you have to connect it. A lot of simulation has been done, computer simulation, when the flow will be maximum, when I can draw what type of design I make, so that like suppose it is the intake pipe, it is coming from the air cleaner side. I think I can just, if there is a picture, I can just, yeah. So this is the air cleaner, okay. Air is going in, and here it is entering, and here it is entering into the engine. So this is the intake manifold passage, right? And now it has a one valve. If I am making two valve here, are you understanding me? Then this whole passage has to be redesigned and optimized, and the shape of that is very important. So after 6 months of simulation, when we started making the prototyping, you know what type of design comes out? The design was like a nose. Nose is white, like there are two intake and they are merging in one. The shape of our intake system. So this is the best design. The nature has designed in such a way that you can inhale maximum air with little bit effort, very little effort. Because if the shape will be like this or like this, you would have put more effort in inhaling the air. So your intake system is like your nose. So there are air filter, your small hairs are there, they filter out the dust, and then the flow should be without any restrictions. So this is what air intake means. Now I was talking just for your another function of this is, as I have discussed, your dust holding capacity, how much dust it can hold before the terminating pressure drop. Another important aspect is it also damps the air noise, because every car or motorcycle, it has to meet the bypass noise regulation also. The noise of a vehicle or a car should not be more than 72 dB level. If it is making more noise, it is not passing the regulation. So noise regulation is also you have to meet. If you remove the air cleaner, even many cars, along with the air cleaner, they are using a resonator also. The purpose of the resonator is to dampen the high frequency and low frequency noise. So that is designed for that, so that you can meet the noise level regulation. So it also helps. You remove the air cleaner, you see engine become more noisy and like that. Good design provide more area of filtration. Like I told you that pleats are there, number of pleats. There is the number of pleats, depth of the pleat, dia. All these are the design parameters. And pressure drop across the new air filter is around 1 kilopascal approximately. And as it become older and older, as it accumulates the dust, the pressure drop is increased, and the terminating pressure as a design parameter, I can tell you, it is around 4 to 5 kilopascal. If the pressure is increased to 4 to 5 kilopascal, I should remove the air cleaner and I should clean it, or I should put it back. And filtration efficiency, very interesting thing. One more thing I am going to tell you. Do you know that generally if you buy any product, their efficiency, if it is a new, efficiency is more. Maybe after usage of the time, the efficiency is reduced or increased? Huh? Reduced. Do you know any system where after usage the efficiency is increasing? No, engine efficiency is reducing. That's why after 2 lakh kilometers we are overhauling the engine, it is totally scrapped. The component which we are talking about, air filter, the cleaning efficiency of the filter when it is brand new, it is around 98.5% or 98%. And when the dust is accumulated in that, the pore size is reduced and cleaning efficiency or filtration efficiency is increased, but at the cost of higher pressure drop. Are you getting me? But if, because the function is clean the air, older cleaner, air cleaner give you better cleaning efficiency, but at the cost of high pressure drop, at the cost of poor engine performance. There are 3 categories of filter. One is the air filter, fuel filter, and oil filter. In all this filtration system, their filtration efficiency increase when the filter is becoming older, dust, because the pore size, suppose it is 20 micron, that will reduce to maybe 10 micron. So it will increase the filtration efficiency. One interesting thing also I am going to tell you, even in Euro 6, even they are making the filter. Now you can say, okay, my filtration efficiency should be 99%. But my dear, now they are breaking it up. They say filtration efficiency. Suppose if I use a dust particle of 2 micron size and the pore size is 10 micron, the whole dust will go inside? No. So the cleaning efficiency is meant for what particle size? That regulation is, that design parameter is also coming in Euro 6. So it is not a common filtration efficiency. It is that filtration efficiency for 20 micron particle size should be 99.9%. Filtration efficiency for 5 micron particle size should be 40%. Filtration efficiency for 3 micron particle size or 10 micron particle size should be X%. Because if the air is going, along with that, it may be 1 micron, it may be 2 micron, it may be 10 micron, some size will go, depending upon the size of the pore size of the filter media. Because more and more advanced the technology, more and more cleaner fuel I need, more and more precise control is required. So air filter, you see, when you are talking about BS6 or Euro 6, you see, is only EFI, but EFI means each and every part you have to redesign. Okay, so this is what, and for that we are using a nano technology. Mahle company has developed a filter on nanotechnology. You cannot see that, and pressure drop across the air cleaner will be very low, and the micron size they can filter is up to 5 microns. That is with the help of nanotech. So future is also with the nanotechnology. The type of filter, as there may be side mounted, central mounted, then it is a paper type. Somebody was saying oil is also we are using, so we call it oil bath filter. So now with this air filter system I have covered, is it clear to you? So what is the purpose of the, it is like a nose, like I have the hairs in my nose, so it remove the dust particle from the air, and important parameter is how much dust it can hold before the cleaning, that is dust holding capacity. There are 2 other parameters also. Filtration efficiency, the filtration efficiency of the air filter should be minimum 98.5% or 99%, and the terminating pressure drop is the pressure drop across which I should remove the, even in advanced vehicles, as I told you, that I am putting a pressure sensor which gives me the delta P across the filter. If the pressure drop across the air cleaner is limiting that a alarm will come in the vehicle, please change your filter, or a light will blink. Because you, a user, you don't know when he should clean. He will just follow the condition, okay, clean it after 5,000 kilometers or 10,000 kilometers. But my dear, that 5,000 and 10,000 is not very true situation, because it depends under which driving condition you are driving your vehicle. If you are in Rajasthan, in dusty area, the 5,000 may not be true. You have to clean your air cleaner in 1,000 kilometers. The real aspect is what is the pressure drop across the air cleaner. So it is a very generic statement that clean your air cleaner after 5,000 kilometers. It is very generic statement. Are you clear? Okay. Now, can I move to the next point? It is a throttle body. Now, throttle body, you see here. Now, air is coming from this side, from the air cleaner side, right? Can you see this arrow?
Yes, sir.
Air is entering here, and this is the throttle body. If I open the throttle body more, then it will allow more air, and this is going to the engine. Now, very important aspect here for Euro 6 point of view. Number one, in Euro 6, hydrocarbon emissions, generally, one thing you should know, why CO is formed, why hydrocarbons are formed, why NOx is formed. Because when I know the reason, when I know the root cause, only then I can take some countermeasure. If I don't know why CO is producing, how I will remove it, how I can reduce it. So CO is mainly the function of the air fuel ratio. As I told you, hydrocarbon is produced due to the quenching effect of the flame, and it is mostly produced at the walls of the cylinders. The surface area, which is cooler comparatively in the combustion chamber, because inside the combustion chamber the temperature may be 1,000 degrees Celsius, but at the walls it is low. So when the flame is traveling, so it quench there, or area which is not exposed to the combustion. So with that, now what they do, earlier they say, even now in three-wheeler, they say, okay, you warm up your vehicle for 40 seconds. Even in two-wheeler, you can warm up your vehicle for 5 minutes. You can drive on the driving cycle for 5 minutes. They will not measure your emissions. They allow you. But sir, that is not true practically. With that emissions during that time also going to the environment. But regulations say, okay, warm up this, because the technology, existing technology was not suitable if you are measuring the emissions from the beginning. In cars, they have deleted that time. So we are not allowing you. In car also earlier 40 seconds was the time you can warm up your. So you start your car and keep 40 seconds on before taking the emissions. By that time, because now I am sharing with you a very important aspect. 80%, my dear, 80% of hydrocarbon emissions are produced during the cold start period only. During initial 1 minute. Total driving cycle is of 10 minutes. 80% hydrocarbon emissions are produced during cold conditions. When engine become hotter, hydrocarbon is reduced drastically. So what we do? It is a challenge. Whenever I start the engine or vehicle, I want that engine should warm up quickly, as early as possible. But if we don't know what is the root cause of hydrocarbon formation, I cannot take the solution. It means I can think now, what should I do? to warm up the engine quickly. Say in just after 10 seconds, engine is attained optimum temperature. So there I can utilize the waste heat recovery. I can use some concept which help me in attaining the high temperature. And with that, another thing, suppose practically the problem which is coming, if you are going to Leh Ladakh or any cold conditions, this throttle, now this point you listen carefully. This throttle, when you are not putting the accelerator pedal, foot on the accelerator pedal, this position is like this. So when this position is like this, it will send around 80, suppose around 5 milligram of 3 into 15, around 45 milligram of air it will send, just for example. And the data is very close to the real for 800cc engine. 45 milligram of air is going to the engine. Now, you have gone to Leh or any cold place. This throttle will remain same. You are not changing this throttle. But there, because it is very cold, you have to inject slightly more fuel quantity, and you have to also increase the slightly more air. And now by foot you cannot do that. It means there should be some mechanism which change the quantity of air as well as fuel. Fuel you can change by changing the duration of injection. With the issue, you can have a lockup table, you can do there. But how to do this? I have to increase, I have to control the quantity. I have not, because I am at idling. How I can make the system that my engine can take different quantity of air depending upon the temperature of the environment. For that, we have designed a idle air control system. This is little bit one mechanism, but now we have another, but you understand the system. What I will do, you see, I will set in this, suppose here 45 milligram air is going across the throttle valve. Now, can you see this? I have a bypass valve. Some part of the air will go from here, and then it will enter, and then it will come from here. And this valve, this I can control through the ECU based on the temperature. Suppose temperature is 0 degrees Celsius. You need 50 milligram of air. 45 milligram of air will pass through the throttle, and 5 milligram it will open such that it can supply the 5 milligram of extra air. And this is all a calibration. My dear, I tell you, calibration is a very, very, very peculiar art. Because if you touch one parameter, 5 parameters go out. If you touch one, so it involves a lot of experiences. Even the person I was in, we are supporting Hero Motor Corps, which is known as Hero Honda, because their R&D center is in Jaipur now. So we are training their whole team on EFI. There are around 38 engineers up to GM level. So we have started a course 3 months before. So we have signed a MOU with the Hero Motor Corps and training them on the how to design and develop a electronic fuel injection system for a motorcycle and single cylinder engine. Now their R&D head is from Austria, who is engine head, and he also said that we are struggling for calibration engineer. In India, there are only 3 or 4 calibration engineers, keeping in mind all Toyota, Honda, and all these things. Because real calibration, main calibration is happening overseas only. Here they are just doing fine tuning. And our engineers which are working here, they know superficial calibration. Because main calibration they do, here they do just fine tuning. So this is a subject. Knowing EFI system is one part. Doing calibration required around 7-8 rich experience in calibration. Only then you can little bit understand the ABC of calibration. And this part in vehicle, I tell you, idling calibration is only one part. And this idling calibration, cold startability calibration, it takes 2 to 3 months, which I am telling you, complete EFI system in 1 hour or 2 hours. The one part, only idling calibration, I have to spend minimum 2 months on the vehicle to optimize it. Mass emissions, I have to spend 4 months. Drivability, I have spent 2 months. And then hills testing and all that, another 1 month. So it is a complete job of approximately 1 year. Calibration. After, when my system is working, it is so peculiar. And not only, suppose you have done on one vehicle, very, very challenging task. Sir, in production, I have to produce 1 lakh vehicles. The tolerances are there. Engine compression ratio may not be same identical because there are tolerances. Injector flow rate, which I have used. The injector making person, he cannot give me the injector of the exactly same flow rate every time. If the flow rate spec is say 160 ml per stroke, it may vary plus minus 1%. And if you look at the engine parts, all temperature sensor, map sensor, injector, ignition coil, is you all having the tolerance. If you consider the tolerances of all, my calibration may go as wire. So what we have to do, it is very challenging. I have to make 3 vehicles. 1 vehicle I have to make by considering the lower limit tolerances, which will make my engine, if the condition, if injector flow rate is low, oxygen sensor is at lower value, all I can make. Another limit sample I make when the limits are on the higher side, and 1 medium. And to making those limit sample, it is very challenging. I have to select, I have to tell that person, okay, give me these limits. And it is 1 knot part. In engine, I am using around 300 parts. All 300 parts, even piston rings, I have to consider all these things. What will the compressions of the lower side? And those sample when I will, so I am fixing the boundary condition. It means I am developing a vehicle and engine, considering that 1 is extreme in that limit, 1 engine is and vehicle is extreme, that limit. And then again, I have to do the final calibration so that whatever type of component will come in this range, it should meet my BS6 emission. Now, can you imagine how much challenges it is? Even catalytic converter, precious metal, that is also a limit sample we have to do. Because the loading again, it may change. Process parameters may change. Little variation is always there. So this is a very, very typical phenomena. That's why not only in India, in world level, you can count calibration engineer. They are not more than in hundreds. In world level, I am talking about, who understand the calibration. So this ISC valve, this is very important. And cold startability, again, in a car, suppose you switch on the AC. If you switch on the AC, you are not supposed to press the throttle at that time. When switching on the AC, load is more on the engine. Engine should be sent more air and more fuel. Again, who will send the more air? You are not pressing the throttle at that time. And neither you can do that. So automatically it is taken care by idle air control valve. So idle air control valve technology, you can do 10 PhD, 20 PhD, 30 PhD only on these reasons. देखिए मैं आपको बताता हूँ, when we were in undergraduation, when we have done our graduation, we thought I know each and everything. I know thermodynamics, I know fluid dynamics, I know drawings, design, theory of machines. I know all properties, materials, metallurgy. You can ask anything. We were thinking like that. When we have done masters, we know something. And when I was in PhD, I was doing only on engine and engine management system. Then I realized I do not know anything. And when I went for postdoctorate in Imperial College of Science and Technology, London, then I found that I am totally ignorant. There is so much to learn, hardly I know anything. So today, the statement is taken as an expert. They say there is expert. But really, I am telling you, I am not expert. I know very little about the engine and engine management system, because there is so much that I have realized after doing my postdoctorate and after 20 years of experience of industry. I can say now that I know very little. And I was in the impression when I was fresh graduate, I know each and everything. Okay, because when you go at micro level, then you will think that there is so much there. Even what I am talking about, even ISC, the design of ISC wall itself is very critical, because you have to control the flow from 1 liter per minute to 400 liter per minute, and controlling the airflow very precisely is a very challenging task. The sealing of that, the control of that, controlling mechanism, when you design it, make a difference. Now, one type of idle air control valve I am sharing with you. It is very simple. It is stepper motor type. So, stepper motor means when you are just giving supply to it number of turns, it moves forward. So it is opening and closing the air passages. And this is you can see when valve steps are increased, airflow will increasing. So by moving the steps, this type of valve I have used, we have developed an engine or 800cc engine on LPG in Maruti. So we have used this type of valve, and the motor has 218 number of turns. And in 218 number of turns, it moves around 7 mm. So per turn, you can calculate how much movement is there, and from there you can do all the calculation of the airflow. My dear, this is, I am saying you, actual flow rate of cars. Here you can see duty ratio. Duty ratio means if my air control valve, if it is fully open, it is 100%. And if it is 50% opening, it is 50%. It is 60% opening, 60%. And around below 15, it is almost closed. So you can see, when this is the test bench data, when we design, we find that at 100% duty ratio, the flow is around 400 liter per minute. Now, two colors are mentioned, pink and dark blue. Upper is the maximum limit, because if I am making a mass production valve, so if I am making 1000 valves, so all the data came in between the flow rate data. This is the production variations. When I was talking about that production variation, this is what limit sample means. Means I have to take one sample of this and one sample of lower minimum flow rate. And this you see here, what I have done, when we are making the car, just car come out of the plant, we check all the parameters. So this brand new car, which is clocked 0 kilometer, which is just taken the birth, I have checked all this. These are the number of vehicles. We have checked around 50 vehicles. In all the 50 vehicles, you see duty ratio at idle is varying from between 10 to 18. So there, what the purpose is, we have the diagnostic tool. I will set that during idle air, the duty ratio may change from 10 to 20. If it is more than 20, it will indicate the fault. But before that, I had to check like this 1,000 vehicles to identify that, because if I have set suppose 15 and the vehicle comes at 20, so it will fail in the. So this is a very important exercise. You see, the whole car, I am using the same part, same design, everything is same, but it is, you see how it is varying. Car to car duty ratio. Theoretically, it should be same. Am I right? Because I am not changing the engine, I am not changing anything, but it is the variations. So this is the idle air control valve. So idle air control valve is useful whenever you are switching on the AC or you are switching on electrical load. Suppose you are switching on the headlights. Electrical load increases, power from where it is coming? Engine. Or you are in cold condition, due to the temperature variation, it will compensate, and any load during idling, it is compensated by the idle air control valve. Is it clear? Now with this, I think I have covered the air intake system. Duty ratio ये है, like if suppose wall is I am supplying 12 volt and then I am supplying 6 volt. At 12 volt it is opening 100%. At 6 volt it is opening 50%. So duty ratio is जितना आपने खुला है जितनी उसकी capability into 100. That is duty ratio. Fuel delivery system. I have to move a little bit faster because there are 3 chapters which I have to cover, because I am going more deeply. That's why it is taking time. But there is a lot of things to cover. Fuel delivery system, like you can see a slide. It is a fuel tank. Then we have a fuel pump. Then we have a fuel filter, and then we have a fuel injector. And we are injecting at a controlled pressure. So generally, pressure fuel injected at around 2.9 or 2.8 or 3 bar pressure. In motorcycle, it may vary, like Yamaha is planning to inject at 2.8 bar. Hero Motor is planning at 2.6 bar. So it is the design parameters, but it may vary from 2.5 to 3 bar. You can note down this. The fuel injection pressure generally is 2.5 to 3 bar. In car, it may be 3 to 4. So this fuel pump, as I was discussing you, at this moment, we are using a constant speed pump, electrically operated. It is operating at 12 volt and it supplies the appropriate amount of the fuel to the engine under all operating conditions. And my limitation is, for a bike, I am using a fuel flow rate of around 40 liter per hour. And bike never use that, because till now, there is a no variable fuel pump is designed in all the cars. So they design what is the maximum flow rate the car need, and if it is in idling, maximum fuel comes back to the tank, which is a wastage basically. But they keep the flow rate and RPM of the pump constant to avoid any complication in the design. But there is maybe a need to design a variable speed fuel pump. But all these things we can understand when we are going deeper and deeper. But when I realized, like I am giving an example of, suppose Swift car 1.3 liter, the flow rate is around 80 liter per hour. And the maximum requirement never go more than 6 liter. So the fuel flow rate is 70 liter extra. Why? Because I have to maintain the pressure, and secondly, I have to design, because I cannot reduce the flow rate. I don't have the variable speed pump. But now we are trying for a variable speed. So if it is in idling, suppose requirement is 1 liter. In idling, approximately you need 1 liter of fuel per hour, for example. And when the engine is running at full load and full speed, you may need around 12 liter. So my requirement is 1 to 12. And I am using a pump of 60 liter or 70 liter. So I am consuming more power. And when it is at idling, it is too much excessive fuel, it is returning back. And what is the problem again? If the fuel is going to the engine compartment, there it absorbs the heat. And when it is going back to the tank, the temperature of the fuel rises. Your evaporation losses increases. The temperature of the fuel tank, can you imagine, it goes up to 65, 70 degrees Celsius because of this. Then they find out another solution. In the pump itself, they put the return circuit. The excess fuel will come back, short circuit there. But then it causes a vapor locking problem because the fuel which is going there is no return circuit. And when you switch off the car, the fuel is there, and when it is heated up, vapor is forms. That causes vapor locking. It gives you trouble in summers. So for each and everything there are, but the best way is I supply less fuel. Right. So this is another thing. Now come to the parts of this fuel system. You have a fuel pump, you have a fuel filter, you have fuel pressure regulator, delivery pipe, and fuel injector. So this is a operating range in India. Now again, very interesting story. You know that CLO car, Martis and CLO, the Dev has launched. I think they were the first peoples when they have launched EFI system in 99. And many cars are standing on roads. There are a lot of challenges. What happens? Because the technology is designed somewhere else, keeping in mind the environmental conditions of that particular country. So Hyundai, they have designed for as per the Korea or Japan. So the pump which they have designed, that is capable to withstand around 55 degrees Celsius temperature. In India in summer, the temperature go up to 65 in the fuel tank. The pump fails. They were not, because if suppose you have purchased the car, you don't know what is happening. You know the engine is not started. You don't know fuel is coming or not, what is happening, you don't know. Consumer don't know. So when he is starting that, he is not able to start because the pump which is mounted in the fuel tank, it was designed for a temperature of, operating temperature of 55. Then we have redesigned that pump. Then another problem, then we have launched the EFI system in Maruti in 2000. We face a lot of problem in injector, lot of problem failure in pumps. The reason of that is due to the poor fuel quality. The pump fails because there was more sulfur and there is a shaft. You know, I can show you the, if here, this pump is sort of a rotary pump. Can you see this? So here there is a shaft, and when your car is standing, so the sulfur in the fuel that start depositing on the bearings. So the OD of the bearing is reduced. The shaft which is rotated in it, the tolerance becomes less and it becomes tight. It is difficult to rotate the pump. You know, even problem analysis, you require a deep analysis approach, because whenever any things fails now you are looking at the vehicle at that time. First you have to pinpoint where the problem is from the vehicle, whether it is in the engine, whether it is in the piston, whether it is in the spark plug, whether it is in the ignition. First you approach to the pump. You are able to arrive there. And if pump is there, then you have to, there are maybe around 80 child parts in this, which causes the problem. So this is the problem. Another point, when there is a winding is there, that copper wire is there. If there is a acidic nature of the fuel, it eats the copper. It will not allow the current to pass through. So again, we have done the modification in the pump. When the Swift diesel was launched, the pump was from Germany. So we asked them, okay, because we expect that it should meet around 20,000 kilometers of, 20,000 hours of reliability.
They say, okay, we have done in the Germany and it is a. You told me we don't want that it should meet the reliability in Germany. Because fuel you are using, which is available in Germany. My fuel quality is different. And even my fuel quality is different when you are getting it from Rajasthan, from Punjab, from Jammu, from Kashmir, from UP, from Chennai. Fuel quality is varying from petrol pump to petrol pump also. So what to do? Either send the fuel from here or get it tested here. So these are the very important aspect when you are developing a vehicle and when you are putting it on road, and to address the issue of the local environment. Because I know in my country, there is a possibility of adulteration of the fuel. I know this. Another problem we observe, many problems come from the Bangalore. What is the problem? There, the people are mixing even water. Water contents were very high in petrol. So injector, that plunger is there, it got rusted and it is not moving. The vehicle not started. Then we cannot ask that you don't mix the water because you cannot control the 120 crore peoples, but you can control your technology. Then we have developed we have changed the material of that needle. Problem sorted out. So that's what, whenever you are developing the technology locally, then you have to make a lot of changes depending upon the environmental conditions, depending upon the fuel availability and fuel quality also. So pump is a very peculiar part of the same. And we have fuel filter. All we know, however, there is a mean pore size, which I was talking is 8 to 12 micron. Actually, there is a lot of things in this also, but I'm just broadly I'm telling that efficiency should be more than 90%. Flow rate is varying from 40 liter to 80 liter depending upon the capacity of the engine. Then we have the pressure regulator, which is able to supply the fuel at constant pressure. It regulates the pressure, and generally it is the design parameters. You may make it for motorcycle, generally it is 2.5 to 3 bar, 2.8. It depends upon the designer, but range I am just telling. So this is the principle of operation of the pressure regulator. You have a diaphragm. If fuel is excess, it will be released back to the tank and only appropriate pressure is maintained at the tip of the injector. I will be little bit faster because of the because there are a lot of things to discuss with you. About injector, I have discussed. This is a sort of a solenoid valve. We have the winding. I may have the cut section of this here. Now you see, it is at this moment there is only one company which is manufacturing this injector in India. That is a Denso, because you need very high volumes in millions to make it viable for the production. And when you are manufacturing this injector, you need 7 grade cleanliness level. 7 grade means like a OT where doctor is operating you. Even the person who are assembling, you are not able to see their body part. Complete head is covered, eyes, mask is there, hands, everything is covered. No body part is visible when we are assembling the injector and testing there. Because even during assembly, the size of the hole where the fuel is injected, it is in micron. And if smallest particle, suppose that size is 80.8 and dust particle is settle of 0.9, it will block that. So your injector at the assembly itself is failing. So this is a very, so here, although I have used, there are 3 grade of filtering I am doing. One filter I am providing at the fuel pump, which is we called it suction filter. Then I am providing one fuel filter, which we have discussed in the line in between. And third filter you can see before entering to the injector. Again, I am providing a filter. So 3 grade cleaning is there, so that you are
at different stages, different micron size, you are holding the dust. When this fuel is coming, this is entering here like this, and you can see this is the coil. When you are sending the current to the coil, it energizes and it pull this needle. It lifts the needle and fuel is all around this, and fuel is injected through this hole here. This is the nozzle plate, and in nozzle there are small holes. Now again, the number of holes may be 1, number of holes may be 2, number of holes may be 3, number of holes may be 4. It depends upon your spray pattern. Even this is a PhD. You can do 100 PhD in this area. Only optimization of the nozzle and spray pattern. So because spray pattern, the engine told me, okay, your spray angle should be 15 degree or 20 degree or 30 degree or 40 degree. Location of the injector, orientation of the injector, spray angle of the injector, they play a very vital role in mixer preparation. So injector is clear. This is the cut section. This is a real cut section of an injector. And the operation, this is controlled by the ECU. It opens and closes. When the current is supplied, it will open. When current is not supplied, it is closed. And just typical example, there are these 4 parameters are very important: static flow rate and dynamic flow rate. Do you understand what is static flow rate and dynamic flow rate through the injector? Static flow rate is, I am opening the injector for 1 minute and I am collecting the fuel in 1 minute, how much fuel it is able to inject. Dynamic flow rate means for a 1 minute, I am not operating continuously. I am giving pulse of 2 milliseconds. Open, close, open, close, open, close, open, close, open, close. But actually in the engine, it is a dynamic flow rate which matters. But from the complete capacity of the injector to know, I have to go for the static flow rate. So that is for this injector typically 175 cc per minute, and dynamic flow rate is 3.6 millimeter cube per stroke, and stroke duration is 2 milliseconds. Spray angle is 15 degree. It may vary from, I told you, from design to design, and the number of that in this is, it may be 1, it may be 2, but now we have the 4 hole injector also. Now, I think it will be clear to you, when I am giving any pulse from the ECU, it will open the injector for a certain time, which may vary from 2 milliseconds to 10 milliseconds, depending upon the load and speed on the engine. And this, at what time it should open, that is the start of injection. For how long it open, that is the duration of injection, which is in microsecond or in millisecond. And this is what to be calibrated. Now, again, there is an important strategy, because when your engine is, suppose you came in the night, you keep your car in the parking. When in the morning you are starting your car, one is temperature is low. Another thing is, to start the engine, I want engine should be able to start as soon as possible. Because if it is taking 3 or 4 revolutions even without firing, all the fuel will go unburned, and that will increase your it is pure hydrocarbon going. So there is a regulation that your engine should be able to start within some milliseconds. And to beat that challenge, now when you stop, your piston may be here, your piston may be here, your piston may be here, and your piston may be in intake, your piston may be in exhaust, your piston may be in compression, your piston may be anywhere it may be. And suppose it is at an extreme level, so it has to complete minimum 2 revolutions to come to the back to that point. and ECU has to identify that. So you have to wait for that. So to avoid all these things, what we do to make it a quick start, we use a asynchronous injection. Asynchronous injection is, I am not using timed injection. Whenever engine start cranking, immediately I will inject little quantity of fuel. And when the time will come TDC, where I want to inject, then again I will inject appropriate quantity. And this I have to optimize very, very carefully. The idea is I can start the engine in only 1 cycle or maximum 2 cycle. 1 cycle means 2 revolution or 4 revolution. We have checked the startability, and in MPFI we are able to start the engine in within 400 or 500 millisecond, because cranking RPMs are, do you know what is the cranking RPM of an engine? When I am cranking, engine is rotating at certain speed, that is known as cranking RPM, and that RPMs are around 400 to 500 depending upon the vehicle to vehicle, or broadly it may be 300 to 500.
Can we continue after the same topic we will continue?
Okay, थोड़ा सा मेरा 2 इसमें बच गए हैं, ECU and all that, so I will spend another 15-20 minutes and then we will start with the alternate fuels, because next session is more on alternate fuels. तो मैं इस पे आपका मेरे को ये कवर करने में थोड़ा टाइम लगेगा और 15-20 मिनट. The idea is, because it is not whatever we are speaking you should be able to digest. So that's why we are going a little bit more deeply. We are not going superficially. So there, and what I expect that when you go home in the evening, you should be satisfied. You should be happy with yourself that today I have learned something. Is it okay? Okay. So now we can have a lunch break, and we can meet at 2, quarter to 2.
2 o'clock.
2 o'clock we will meet, and then we have a long session that I think till 3:45. 3:45. So 15-20 minutes I can spend on EFI system, and then 1 hour we will cover the alternate fuels. Okay.
Yes, sir.
ठीक है सर, बाहर से कुंडी जरूर लगाना।
ठीक है सर. Yeah. Okay. Yeah.
आ गए हैं लड़का लोग।
Okay, now can we start?
Yes, sir.
Now we will start when and how we are controlling the injection. So there are two factors very important. Number one is what we call it basic duration of injection. We call it a basic table. Based on the air flow requirement, what is the air going on, we calculate what is the amount of fuel is required. Then based upon the injector characteristics, we know this injector is capable to deliver 2 milligram of fuel in 2 milliseconds. And suppose requirement is 3 milligram. It means 3 milliseconds is the duration of injection. So that we call it very basic. This is the start injection duration, basic. Now this is not sufficient. Very important thing is happening. When you are cranking, what happened during cranking? Engine to start in you are. Your injector is there, ECU is there, pump is there. You ignition on. Switch on the ignition. When you switch on the ignition, then you start cranking. Cranking means you are trying to rotate the engine with the help of a starter motor. That is the cranking. When you start the cranking the engine, the starter motor is drawing very high amount of current. That is in the order of 100 ampere. Because it draws very high level of current, because it has to rotate the complete engine. Because engine is idle. It is not moving, it is stationary. So to rotate the whole mechanism, you need lot of torque and power. That is provided by the starter motor. Now when the starter motor is providing, it draws very high current. From where it will draw the current? From the battery. When it will draw high current from the battery voltage is generally 12 volt. That voltage drop down. This is a very, very peculiar behavior. When the voltage is pressed down, it means your pump and injector, the flow rate characteristics are designed for at 12 volt. When the voltage is dropped, suppose a injector, when you provide 12 volt, in 2 millisecond duration of injection, it injects 2 milligram of fuel. But when the voltage drop is suppose 10 volt, the quantity of the fuel to be injected will reduce. So during cranking, it is a different behavior. I know it will, suppose I tell you, during cranking, due to the voltage drop, the fuel quantity will reduce by 10% in the same duration of injection. So then I have to provide a correction factor for this during cranking. Get me? And this is what the battery voltage compensation. So I will continuously monitor the battery voltage. If the battery voltage is low, and battery voltage may be low due to any reason. Sometimes battery voltage is low because of the life. Sometimes battery is discharged. Sometimes due to any reason. So there is a correction factor which is known as battery voltage correction. So if the voltage is low
or sometimes voltage may be higher than 12 volt, because when the charging system is there, the voltage is around 13 volt or 13.5. So at that time you have to again apply the correction factor. So basic duration of injection is what is this one. Okay. Then voltage correction, this red one, and this is a correction coefficient which may be due to the air temperature, because as we have discussed a lot, when the temperature of the air changes, air density changes, mass of air will change, accordingly quantity of the fuel to be injected will change, and to make that change happen in duration of injection, this is the correction factor, blue one. So final duration of injection will be this plus this plus this. Clear? And like this, there may be more correction factor also. Like there may be a engine coolant temperature, there may be a intake temperature correction also. There may be you can add atmospheric pressure correction also. But these are the correction factors. So final duration of injection is equal to base duration of injection plus correction factors. And correction factor may be due to any reason, like battery voltage, like air temperature, like coolant temperature, means engine temperature, maybe on depending upon the atmospheric pressure. It is the same thing, voltage correction. Why? The injection volume and rate of opening of depend on the applied voltage across the injector. If voltage is low, opening may change, right? This is what we are calling, and hence this voltage correction factor is implemented. This is the fundamental behind that. Now, normal injection volume, this is about the calculate injection duration, base injection duration, correction coefficient, voltage correction, what we have discussed with you. Now correction coefficient, there are different things. Very important, first is when we are cranking, I need, you know, earlier you were providing a choke to start the engine in the early morning or in the winter. Now there is no choke in EFI system. What the choke means, it is making the mixture rich. So there is a enrichment circuit, enrichment strategy. The first thing is what I am writing, start enrichment. And there may be a cranking strategy also. During cranking also you need a strategy. When it is started, warm up enrichment. That, like I had discussed with you, in Euro 4 or in Euro 6, we want to warm up the engine as quick as possible. Normally, a engine take 5 to 6 minutes to warm up. Now, my purpose is how to reduce the warm up period. So this we can change, and there are two ways to do this. Number one, I make high idle. Engine speed I increases in the beginning, maybe 1800, and then as it warm up I make it slowly reduced, and then when the engine is fully warm up it may be 900 or 800.
Question. Sir, at the time of starting, consider I have shut down my engine and the piston is at bottom left center. But now I am starting the engine. How the process will be taking place?
There is a crank position sensor. So as soon as you rotate the engine, the ECU will get the indication when the TDC will come. Okay, so it means it will take some time to detect the TDC. That is in microsecond.
What is the in case of scooter and bikes?
It is same thing.
There is no EFI system.
Then you don't have the sensor, no? then fuel will come with the carburetor. As soon as the airflow will take place, fuel will also start coming from the carburetor.
Means if we will talk about the diesel engine and how will the combustion take place at that time?
देखो आप confused हो रहे हो आप. We are not talking about the diesel engine. So don't make confused with the diesel, because again it is another subject. In diesel engine, I am not controlling the air. Air is coming in the engine. At the end of the compression stroke, I am injecting the fuel through the injector. In diesel engine, there is no carburetor. And the injector will give the fuel. It is governed by the camshaft. So camshaft is positioned, and timings of the camshaft is such that it should inject around TDC. So it is a mechanical arrangement. It will do that. आप समझ रहे हो? अब मुझे आपका क्वेश्चन भी समझ में नहीं आया. मुझे तो समझ में आपका क्वेश्चन ही नहीं आया अभी तक. What you want to?
My question was that at the time of starting, I'm starting my engine. My piston is at bottom dead center.
हाँ फिर क्या है वो जब टॉप बॉटम डेड सेंटर तो टॉप डेड सेंटर पे तो आएगा ना वो जब इंजन घूमेगा.
I'm just asking what will be the force that will pick the piston to up to the top dead center.
हाँ तो मोटर जो होती है क्रैंकिंग करते हो दैट विल प्रोवाइड द फोर्स. जब हम क्रैंकिंग करते हैं इन मोटरसाइकिल, नाउ देयर इज यू कैन क्रैंक इट. इफ यू डोंट क्रैंक इट, आपने देखा ना किक नहीं मारते आप, दैट किक विल प्रोवाइड द फोर्स. Now there are two type of bike. One is you can start the kick. So initial force, the movement, like anywhere the piston stops over BDC. So you make the kick. If you don't, that is a mechanical system. If there is no kick, you have the starter motor. So starter motor will push the piston in diesel as well as in petrol. In tractor engine, you might have seen there is a pulley and you put the rope and then you pull it. So there may be many means. In diesel engine also earlier the people were just being the mechanical. So you have to rotate the engine by external force. That external force may be provided by the starter motor. That may be provided by the kick. That may be provided by the rope. That may be provided by the human effort. Is it clear? Okay. Now these are many correction factors like we have discussed. Intake air temperature correction, I told you. Transient time air fuel correction. Now this is very, very difficult. Transient time means, suppose your vehicle is running at a speed of 40 km/h and you are accelerating and you want to achieve 80. So from 40 to 80 it is continuously changing. So this is the transient time. So during transient time, any parameter is not fixed, not constant. So regularly you have to change each and everything. When you are suddenly accelerating, air will increase suddenly, but fuel will take time because it is viscous. So there is a time lag between. Suppose the quantity of the air you have changed from 50 milligram to 60 milligram. Now to compensate that, you have to change the fuel from suppose 4 milligram to 5 milligram. Now, air will change immediately. Fuel may take some time. It is a time lag. To reduce that time lag, we make the mixture overrich. So we put the fuel in extra quantity. That is known as transient air fuel correction. Power enrichment. Suppose you want to run at a 120 km/h speed. At that time, you need more power. More power means you have to make the mixture. If more power is required, what you have to do? You have to make the mixture. If the power requirement is more, you have to make the mixture. हाँ भैया, रिच वाले हाथ उठाओ. भाई जब ताकत ज्यादा चाहिए तो डाइट ज्यादा लेनी पड़ेगी या कम? लीन का मतलब है यू आर रिड्यूसिंग द फ्यूल. व्हेन यू नीड मोर एनर्जी, जो एक्सरसाइज करते हैं, सपोज आपने स्विमिंग की कंपटीशन की तैयारी करनी है और बॉक्सिंग की करनी है, तो यू नीड मोर एनर्जी और लेस एनर्जी? ऐसे याद रखना आप, इट इज नॉट लीन, इट इज रिच। इसलिए यहां पे लिखा हुआ पावर एनरिचमेंट। तो मेरे को उस टाइम पे क्या करते हैं हम, when we want more power, I identify the zone in the car. Like one zone is idling, one zone is moderate speed. आपने देखा कई स्पीडोमीटर पे ग्रीन जोन बना होता है, that zone is you will get the maximum fuel economy because I don't need power at that time and air fuel ratio is set lean at that time. And after some time the speedometer goes up to 70. After 70 it becomes red or orange. It means here the fuel consumption will be more because that zone is tuned with high fuel so that you get more power, because more power is required. Wind resistance is more, road resistance is more, frictional losses are more. To overcome all these things, if you want to speed of 110, 120, 140, 150, you need more and more power, more and more fuel. It is extra rich fuel. So high power means more fuel. Higher fuel economy means when you want more fuel economy, you have to lean the mixture. Right? So this is power enrichment. Next is air fuel ratio feedback correction. Feedback correction, you might have heard about the oxygen sensor or lambda sensor. Suppose you want to maintain air fuel ratio of 14.5 at certain condition. But due to the dynamic flow rate, it is changing, varying. So I have a closed loop system. I am putting the oxygen sensor that is giving me the feedback to the ECU. No, air fuel ratio is not 14.5, it is 14.9. So reduce, make it correct. So again, it will reduce the quantity of the fuel or increase the quantity of the fuel as per the signal, and it will try to maintain in that window. That is what the air fuel ratio feedback correction. It means there is a feedback of the air fuel ratio. If it is rich, it will be made lean. If it is lean, it is made rich by the ECU. Okay. Idle stabilization correction. Okay, here I just ask you one question. Mostly you know driving. गाड़ी चलाते होंगे आप लोग, है ना? Now I am giving a condition. You start your bike or car. Start your car and stand, come outside the car. Let the car is in idling and keep that idling maybe for 5 minutes. Let it warm up. After warm up, everything is stabilized, and you put a tachometer. Tachometer means you measure the RPM of the car. It is in alright. I am not changing anything. Air is same, fuel is same, quality is same, ambient temperature is also same, atmospheric pressure is also same, everything is same. So should I get the idling RPM constant or not? Constant. I should get the constant. Actually, is the RPM are constant or not? No. Why not? I am not touching anything. Nothing is happening. मैं कह रहा हूं मैंने वार्म अप कर ली गाड़ी, आप समझ रहे हो, एवरीथिंग स्टेबलाइज. आप समझ रहे हो क्वेश्चन ये, नथिंग ऑल, इवन यू पुट ए कंट्रोल्ड कंडीशन. आपने सब कुछ कर लिया, वार्म अप करके 10 मिनट के बाद गाड़ी स्टेबलाइज हो गई. आरपीएम शुड रिमेन कांस्टेंट और नॉट? Theoretically I want, but practically it is not like that. There are maybe more, not in India, but there are many research at PhD only in idle stabilization. जैसे हम कहते हैं यार कोई बड़ा एक प्रोजेक्ट लें, idle stabilization, cyclic variations on idling. This is a very interesting area of research. First, I tell you, even after warm up the engine, suppose manufacturers say 800 RPM, idle RPM. Engine never remains at 800. It is fluctuating between 850, 840, 830, 810, 790, 750, 760. It is like that. And all cars, maybe Honda, maybe Toyota, every car.
But the reason is because when I am going for Euro 6, this is killing me. I don't want this. The first thing is, what is the reason for this? Piston पिस्टन तो मूवमेंट करेगा ही करेगा।
हर बंदे की जो 4 सिलेंडर इंजन है,
हाँ,
हर सिलेंडर की उनसे होगी टॉर्क आरपीएम बदली आएगी।
क्यों? वो आपका मैं आपका वो केस भी न्यूट्रलाइज कर देता हूँ, दैट इट इज अ सिंगल सिलेंडर।
So there will be not 100% efficient combustion every stroke. In every stroke.
So ठीक है, whatever the combustion is there, I am not changing any parameter. Suppose combustion is not 100%, it is 90%. Let it be 90%. फैन भी छोड़ दो आप, फैन चल ही नहीं रहा, निकाल दो फैन को।
जैसे इंजन का टाइम बढ़ेगा चल रहा है तो उसका कंबशन एफिशिएंसी बढ़ जाएगी, तो जो हमारे पास बाय प्रोडक्ट्स आ रहे थे।
लेकिन वो अच्छा बढ़ जाएगी तो एकदम इम्प्रूव होनी चाहिए। वो अब वो ऐसे इम्प्रूव नहीं होती ना, वो कम ज्यादा ऐसे फ्लक्चुएट करती है। यदि आपका मैं वो आर्ग्यूमेंट तब मान लूं मैं, पहले 800 थी 900 होगी 1000 होगी, कंबशन एफिशिएंसी इंप्रूव करके बढ़ गई आरपीएम, बट इट इज नॉट इंक्रीजिंग। लिसन टू मी, आई एम टॉकिंग अबाउट द फ्लक्चुएशन।
So this can depend on the density of the air.
Density of the air is not so dynamic, the temperature is changing. I am maintaining, even if you maintain the density constant, again it will vary. So this is the, I think, food I am giving you for thinking, for your brain. Just think. For this, what is the root cause of cyclic variations in idling speeds? And you can get a lot of material also. And then if you get about the spark ignition engine, then you can also go through the diesel engine also. But first go for the spark ignition engine. So idle stabilization is what I want to avoid the fluctuation. That is the calibration of that. High altitude correction. What is high altitude correction? When you are going at the hills around 15,000 feet height, 16,000, atmospheric pressure is decreased. What is the atmospheric pressure generally?
1.013 bar.
In terms of kilopascal, around 100. So, and at the hills, what is the pressure you found? Maybe 95, 96 kilopascal. So that 5 kilopascal is reduced. If that is reduced, your air density changes, and you are able to, because outside, now how the flow is taking place, outside is the pressure, engine is creating the vacuum, so that delta P will be changed. So amount of air going to the engine will be reducing. For that I have to provide a compensation, which is not possible in carburetor. If less air is coming, then I have to reduce the quantity of the fuel also. Okay. So I am naming some correction factor. Even now, 1, 2, 3, 4, 5, 6, 7, 8, 9. Around 9 correction factor is there. And calibration means you have to optimize each and every step. See, that's why I'm saying calibration is a job of 1 year. If you work 24 hours is so morning to evening. Now next is fuel cutoff. This is very interesting. I told you also. Suppose your car is going at a speed of 80 km per hour speed. Due to any reason, you are stopping car. Whenever your de-acceleration mode, I want that fuel cutoff should take place. Fuel should supply cutoff, so that your pollution is low and your fuel economy is better, because I don't need power at that time. So this is what you have to tune it. But fuel cutoff to kiya aapne. But when you have to restart the fuel, that is another important point. So these are the some correction factor. So basic duration of injection plus this correction factor give you the final duration of injection. So these are the elaboration of all these warm up. ये कैसे करते हैं, temperature curve वगैरह हैं. What I have told you. Air temperature correction factor. If the temperature increases, how the correction factor is can vary.
transient, acceleration enrichment. This is what we call air fuel ratio feedback. There is a lambda sensor, or in lean mixture, the oxygen sensor output is towards 0. 0 means it may be 0.1, 0.2, 0.3 at exam. And it is maximum at rich mixture, it is 1 volt. The voltage of this lambda sensor will vary between 0.1 to 0.9 volt practically. So accordingly, I get it and I use the correction factor depending upon the actual feedback. Idle stabilization, high altitude correction. At high altitude, atmospheric pressure, low pressure, high pressure. If the pressure is, accordingly I can change the duration of injection. If the pressure is low, I will make the duration of injection low. Deceleration cutoff, I can cut off the fuel supply, suppose at 2000, and I can restart it, fuel cut off, and I can restart. I can make a control strategy. Okay, if the RPM are achieved around 2000, I can restart the duration. If RPM are 6000, I cut off the fuel supply. From 6000 to 5000, cut off. 5000 to 4000, cut off. 3000, cut off. 3000 to 2500, cut off. But when it reaches 2000, it can restart automatically. But when to restart, it is again a calibration. Should I restart at 2000, 2100, 1900, 1800? So that we have to check. There is one more thing to make the engine safe. We call it fly up speed. We also cut off the fuel supply to protect the engine. Suppose somebody is just accelerating and idling. So RPM can shoot up. We call it fly up speed. After that RPM, it may damage the engine. So we can limit that speed also by cutting off the fuel supply. Like in our engine, we do at 6500 or 6800. So after 6800, even if you press it, engine cannot go beyond 6800. Fuel supply will cut off. And when it is less than 6800, it will rejuvenate. Okay, can I now summarize the this enrichment? We have cranking enrichment. We have warm-up enrichment. Then we have acceleration correction factor. Then we have air temperature correction factor. Then we have engine temperature correction factor. Then we have altitude correction factor. Then we have power enrichment. Then we have fuel cutoff. Then we have idle stabilization. And then we have air fuel ratio lambda feedback correction factor. And also we have the fly up speed and fuel cutoff during deceleration. So these are around 10 parameters which you can calibrate. And the basic duration of injection, final duration of injection will be basic duration of injection multiplied by the correction factor, all these correction factors. So suppose basic duration of injection is 3 milliseconds and each is contributing 10%, 10, 10, 10, 10, 5. So it becomes 60%. So it will be 3 plus 50%, around 4.5% of that. That is the how you take the correction. Battery voltage correction factor also we have discussed. During cranking, battery voltage go down, so you have to compensate for that. So is it clear to you? Okay, can I go next?
इंजेक्शन में आप बोला था कि जैसे हमारा पिस्टन बॉटम डेड सेंटर है तो फ्यूल एनालिसिस सिस्टम लगाया तो इसमें फ्यूल इंजेक्ट होगा ऐसे में वैसे तो फ्यूल इंजेक्शन होगा जब टॉप डेड सेंटर से बॉटम को रूल करना स्टार्ट होगा तो उसमें जाकर बॉटम डेड सेंटर होगा तब भी फ्यूल का इंजेक्शन होगा थोड़ा सा
नहीं वो फर्स्ट टाइम होगा एक ही टाइम पे
तो क्यों होगा इंजेक्शन उसके बाद में कैसे होगा
वो आप जो स्टॉक आ रहा है उससे पहले ही कर रहे हो आप that fuel go in the intake manifold.
जैसे फ्यूल प्लांट करवा रहे हैं
हाँ अब जैसे इंजन के अंदर जाएगा तो बर्निंग हो जाएगी उसकी
एक्चुअली में तो बर्निंग जब पिस्टन ऊपर जाएगा तब वो स्पार्क कभी
हाँ तो कभी भी जाएगा that fuel we are injecting into the intake manifold. Suppose your valves are closed. piston. If valves are closed, the fuel will be in the intake manifold, and there it will mix with the air which is available in the air. When as soon as the valve will open, that mixture will get into the
इंजेक्शन कौन सब कर रहे हैं उसकी स्टार्टिंग में पावर चाहिए
हेलो
आप उसको बंद करो ना, आप क्यों ये आवाज आ रही है?
सर आई वांट टू आस्क समथिंग
बोला एंड ऑफ द सेशन पे क्वेश्चन पूछेंगे।
ओके
आप भी एंड ऑफ द सेशन आप इकट्ठे कर लो, लेकिन आपने गलत समझ रहे हैं। मैंने ये नहीं बताया पावर बढ़ाने के लिए, हमने इट विल नॉट इंक्रीज द पावर, स्टार्ट करने के लिए कर रहे हैं हम, क्योंकि तो ताकि क्विक स्टार्ट हो जाए। द फिलोसफी इज टू स्टार्ट, क्योंकि आपका पूरा साइकिल घूमेगा तब मेरा इंजेक्ट होगा, तो उससे मैं पहले ही वो कर देता हूं टू मेक इट सेफर। तो पावर बिकॉज आई एम क्रैंकिंग एट दैट टाइम, ठीक है। नाउ वी आर कमिंग टू द इंजन सेंसर्स। Quickly, I will go through the engine sensor because I have to cover alternate fuels also. It is already 3 o'clock. So there are many engine sensors like MAP sensor. It measures the pressure in the intake manifold. Then we have the throttle position sensor. We have the temperature sensor. जितने भी मैंने correction factor की है वो सारे हम measure करते हैं. We are measuring the air temperature. We are measuring the crank position sensor. We are measuring the cam position sensor. Crank position sensor we are putting to identify the top dead center of the engine. So from here I will find out whether piston is at top dead center or it is at the bottom dead center. My all reference taken from the TDC. This is the most critical. If any sensor is not working, engine can survive, engine can work. But if this sensor is not working, crank position sensor, engine will not start. So this is the most critical, and from design point of view also, this is the most critical sensor, crank position sensor. Number of teeth, how many number of teeth should be there, how I detect the TDC, what should be the missing tooth and all that. And battery voltage also we are measuring and displaying it. So these are the in detail about the MAP sensor. What is the characteristics of this? You can find out in any books. TPS, throttle position sensor, it is a potentiometer type. As you increase, resistance will vary, accordingly voltage will vary. And the temperatures of sensors are basically simple, either your K type or at low temperature, it is a NTC type, negative temperature coefficient type. This is the temperature coolant sensor. Inlet air temperature is also on the same principle. Crank position sensor, it is a Hall effect. When some tooth is coming, it cuts the pulses and it gives a signal. Similarly, cam position sensor, oxygen sensor, this is basically measuring the level of the oxygen in the exhaust gases, and the principle is nest principle. It measures the concentration of the oxygen. And then oxygen sensor, and then battery voltage. We are just getting the battery voltage. We are measuring in the ECU. So we have covered air fuel ratio, mixture preparation. Now intensity of the spark, I told you in the morning, but the important thing is here I want to cover one point, that at what time we create a spark. It is very important. Generally you see, if idling, I am creating the spark at 10 degrees before TDC. So as the speed increases, I have to make it advance, which is known as advanced mechanism. In mechanical system, that advanced mechanism is missing in most of the bike. They make either 10 degree or 30 degree. In between, they cannot vary. But with the electronic injection system, you can feed in the table what should be the ignition timing at 1000, 1500, 2000, 3000, 4000, 5000, and you can get the curves in the same way. Why I had to advance? Because when the engine is moving at a very high speed, time available for flame combustion is very low. So I had to advance the spark timing so that you can complete the combustion. And that we have discussed with you, that there is a ignition coil which has the primary and secondary, and that give around 30,000 volts. So with this, I think I would like to cover one complete system that I will summarize the whole engine management system. You see, this is the complete engine management system we have covered in bits and pieces. We start with the fuel system, fuel tank, fuel pump, fuel filter, then fuel pressure regulator, and the fuel is coming to the injector and going in, injecting at the intake port before the intake valve. We call it fuel delivery system. It is clear. Then air intake system. I have started from here. Air filter, we have discussed a lot. Air intake hose coming to the throttle body, throttle position sensor, throttle valve. ISC, I have discussed it great length. Then air is controlled here and air is entering into the engine through the intake manifold. Is it clear? In this intake, we have the different sensor, air temperature sensor, throttle position sensor, ISC valve, and intake absolute pressure sensor, that is MAP sensor. Two circuit completed. Then third, come to the other sensor. You have the lambda sensor, oxygen sensor here in the exhaust. And then you have EGR. EGR is a technology which we have not covered to control the NOx emissions. So part of the exhaust gases you are recirculating. So in motorcycle engine it will not be done. It is not required, but in car engine it is required. Then you have a ECU. This is the ECU. What is the function of the ECU? All these sensor input, temperature, engine temperature, oxygen sensor, MAP sensor, throttle position sensor, all this feedback will go to the ECU. And ECU will decide when to inject, how much to inject, and it operates the injector as well as ignition system, ignition, spark timings. Correct? So based on the different inputs, it controls the injection duration, start of injection, and spark timings. With this, I want to close my engine management system. This is just sort of a introductory. Otherwise, there is a complete MS course of 2 years on only engine management system. So I try to give you in 2 hours what I can provide you, but this talk may be able to create the spark in you. The people who are interested in this technology, they can start homework. They can read more about this, and anybody is most welcome to contact for any clarification or any question on emails which your faculty can provide you. So I may be happy to help you, right? Now we can discuss. Now you can open the session for engine management system. If anybody has a question, we can reply that.
SRM University, sir, आपके पास mic है, आप call करिए.
Yes, now the session is open for any question. Any question, please? Any question about engine management system?
Yes, sir, I wanted to ask one question.
Yeah, please.
Yes, sir. My question was like while you were discussing, you just told us like while idling on an average car, there is an RPM of 800.
Okay, that depends upon the car to car, but I have taken a specific example of 1.3 liter engine. It is around 800 RPM.
So my question was, how is that RPM decided? Like, why won't we go for like only minimum RPMs or something like that?
Because engine will not run below that RPM for that particular design.
So, sir, the RPM which we set is just minimum, just to overcome the frictional power.
Yes, and it may be different from engine to engine.
Yes, and that means other than the frictional power, we are not losing any energy while idling.
No, this is the minimum energy required to overcome all the friction losses.
Yes,
and just move the engine under without load conditions. And for example, suppose I give you 3 examples. If you have a Maruti Alto, then you have a Swift 1.3 liter. Then we have a 2-liter engine. As the size of the engine increases, because it is a multi-cylinder engine, so your RPM, idling RPM reduces. Alto need minimum 900 RPM. Swift need 850 RPM. Higher capacity engine needs 700 RPM. And if you take a single cylinder engine like motorcycle, their idling RPM are 1000 or 1100. So smaller the engine, idling RPM are more, because it has a less power, and to overcome that it need more speed. So that is the general time. If you talk about the railway engine, the idling RPM is only 150. So there are many factors like what is the moment of inertia, what is the size of the flywheel. So there are many factors, but as a thumb rule, you can say bigger the engine, lower the idling RPM, smaller the engine, higher the idling RPM.
Okay, sir, and when we are running on a constant speed of 90 or something like that, and I just need to apply some brake, or I just go on clutch. So sir, in that condition also engine is running. So sir, at that point of time, what is the RPM of an engine?
Suppose the vehicle is running at 90 km/h speed. It depends upon the gear ratio. For a particular car, like I can take an example, at 90 km/h speed, engine RPM are generally 4000 or 4200. So if you are deaccelerating, so fuel will be cut off. Engine is running because of the moment of inertia, and you can cut off the fuel supply. So engine will keep on rotating, and there is a control strategy or logic. It depends upon the OEM to OEM. Like in my cars, I make a strategy. I cut off the fuel supply till 2000 RPM. When it is slowed down to 2000, if the RPM are coming less than 2000, the fuel supply will start automatically again.
Okay, but sir, while engaging and disengaging, there will be a difference in the moment of inertia. Like I just apply the brake and then I again accelerate. So in that case, our clutch plate can break or something like that.
Oh, no, I don't think that you know the basic of drivings. If you are running at a 90 km/h speed, nobody declutch that engine. Declutch is required when you are shifting the gear.
Yes,
and if you have that habit of declutching, that you are prone to accident, because it is not suggested. If the vehicle is running at high speed, never use the clutch. So your basic question itself is wrong. Okay. Never use clutch when you are running at a higher speed. Use the clutch when you are changing the gears. So when your vehicle speed come down to suppose 30, and you need to change from 4th to 3rd gear, only then you can use the clutch, because the clutch, the assembly power transmission, the transmission basically is responsible for controlling your car. It's not the engine. If you are declutching and making the engine, your car will be unstable and it is prone to accident. Yes, please. Any other question?
अरे फिर चला जाएगा यार.
Sir, I have a doubt.
Yes, please.
Sir, you said that bigger the engine will start at the lower RPM. But in the case of higher engine, suppose it's a V8 configuration or a V12 configuration, the engine boots up at around 2500 to 3000 RPM.
I think you have not heard properly. I say idling RPM are low. Idling RPM, I was telling, idling RPM are low of bigger engine. Okay. And I have given the example that 800cc engine have the idling RPM 900. 1.3 liter engine has the idling RPM of around 800. 2 liter engine have the idling RPM of 700. 2.5 liter engine idling RPM maybe 600. So it is the idling RPM.
Okay, sir.
Okay, I think we can start. We have half an hour. We can cover some alternate fuels. Yes.
All lambdas in the exhaust side. So it's basically to measure the oxygen content, right?
Oxygen content of the exhaust gases.
The exhaust gases.
Yes. Because from there indirectly we are calculating the air fuel ratio used in the car. So it is the analysis. That's why it is called the feedback control. So from here I know what was the air and fuel supply to the engine. If the mixture is very lean, then the oxygen content may be more. So it is calculating the air fuel ratio indirectly. And that's why it's more specifically it is mounted in the oxygen sense in the exhaust, and it is very near to the exhaust manifold, because it start working only when the temperature is around 340 degrees Celsius. This oxygen sensor will not work at atmospheric temperature. Even at 200 degrees it will not work. So the principle of operation required the minimum operating temperature of the oxygen sensor should be around 300. Now the question arises, suppose when you are starting the engine, actually this is a very good question. The question is like, when I am starting the engine temperature is very low. So it means oxygen sensor is not working. So for that, in new technology, we are using a heated oxygen sensor. So we have an electrical circuit in the oxygen sensor here. And as you switch on, high current will flow through that and it will heat the oxygen sensor within few seconds. And oxygen sensor will start giving the feedback immediately when you cranking the engine. It was not in Euro 3, but it was this heated oxygen sensor is used in the BS4 and BS6. In BS3 it is not required. As I told you, warm-up period is there. So it takes few minutes, the temperature is attained. But because the time is not permitted, so I have to use the artificial means to heat it up.
Sir, in the catalytic converter, isn't the oxygen being used again?
No, oxygen catalytic converter, like in petrol engine, there is a three-way catalytic converter. So what we are doing in there, hydrocarbons are converted into H2O and CO2. So it is an oxidation catalyst. One is the reduction catalyst. Reduction catalyst is N2O is broken into nitrogen and oxygen. So when the reduction takes place, oxygen is generated, and that oxygen is used to the oxidizing the HC and all that. It is a both. That's why we call it three-way catalytic converter, because it converts CO, HC and NOx. For CO and HC, it is the oxidation, and for oxidation we are using platinum or palladium, and for reduction catalyst we are using rhodium. So it is a ratio of both platinum and rhodium. Good question. Anyway, anything else? Anji, sab samajh mein aa gaya? Next, can we start with alternate fuels? Yes, sir. Okay. आपने मेरा एक मिनट क्लोज टैब दूसरा कहाँ पे किया था, इसी में है क्या? अच्छा करना एक मिनट, हाँ खोलना अल्टरनेट फ्यूल पे होगा, देखना ये रहा कतरी अल्टरनेट फ्यूल था, एक पीपीटी में ऐसा है ना? यस. How many you knows that we are using alternate fuel? What are the different alternative fuels? And why we are using the alternative? So, number one, because petroleum product we are importing, 80% of required petroleum we are importing. We have only 20% for resources. So we are investing huge amount of money to import the fuels. Secondly, so we want renewable fuels also, because petroleum based fuel may exhaust in another 30-40 years. So there is a need so that we can produce the fuel from the renewable, which is renewable. Number three is to reduce the pollution. So I will just show you, this is the effect I just discussed, because you are importing and you are spending a lot of money in import of the petroleum based fuels, and then environmental degradation, health problem, safety issue, idling period is very high. You can see all these things. That's why idling emissions is also to be reduced. Now, how to control all these things? So I am coming direct to that. One is we can upgrade the engine technology, like engine management system I have discussed with you, emissions control technology, regeneration, waste heat recovery, reduce frictional losses, VCR. There are engine technology upgradation. Another approach is alternate fuel. I use a fuel which is cleaner than the petrol. Like we are using CNG. Why we are using CNG? If you look at the composition of the fuel, by composition itself, it is a clean fuel. It has one molecule of carbon and 2 hydrogen. Petrol has more carbon and less hydrogen. So if you have more hydrogen, because hydrogen is more cleaner, carbon content, higher the carbon content, more is the CO, more is the CO2. These are the different alternative fuels: ethanol, ethyl alcohol, methanol, biofuels, LPG, CNG, liquid natural gas. And another concept is coming up, blend of hydrogen and CNG. Now we have done a project where we have blended because pure hydrogen, we don't have the technology to use at this moment. Although we have started 2-3 engines, some OEMs are also working, but it is not in a production stage. So what we think, CNG is already available. So can we add some hydrogen in that so that we can gain the experience when we are burning the hydrogen, what is the experience? So this is, we call it HCNG, hydrogen CNG blend. Then pure hydrogen. This is very important slide to give you a lot of information. Why I am using the fuel, you see here. This is the CH ratio. Now petrol is coming here, petrol and diesel. So as you move down, this is the butane and propane. LPG is mixture of propane and butane. It is here. Here means the CH ratio will be around 5. Petrol, gasoline is more than 6. If you talk about methane, it is around 3. Means carbon is less, hydrogen is more. And if you talk about hydrogen, there is no carbon. So we are approaching from higher carbon to low carbon fuels, or ultimately carbon-less fuel. If I take you a little bit, like when we started the development, earlier we were using the solid fuels. If you remember, 5,000 years or 500 years, we were using wood and coal. That is the era of solid fuels. So since century we were using that, but that caused more pollution. Now, I think in 1890, we start using liquid fuels. So we have switched from solid fuels to liquid fuel, because liquid fuels are more cleaner than the solid fuels. Then come to the liquid to gaseous fuels. Gaseous means you started maybe in around 2000, LPG, CNG, because they are gas form. In gas, impurity is less, and they are more clean burning properties, and they are less carbon. You see, you can see. If I am using less carbon, if I am using CNG as compared to diesel or petrol, straightway you can note down this without changing anything. I am reducing 25 to 40% of CO2 emissions. Straightway. It is written here, minus 25% minimum. Same engine which is running on petrol, you give CNG, your CO2 emissions will reduce minimum 25%. And a regulation is coming in future. You have to control the CO2 emissions also. Means you have to improve the fuel economy of your vehicles. In 1 liter of petrol, by burning, suppose you are producing 150 gram of CO2. Smaller the engine, lesser the CO2 emissions. So it is a big challenge to the bigger vehicles, because they will limit that in 1 kilometer running, your CO2 should not be 120 gram.
So bigger engines are more challenging. So you have to downsize your engines, or you have to use the hybrid concept, electric and engines, so that partially it is supplied by the. So for BS6 to meet this emission, there is no solution until unless you go for hybrid. So, or this is a very good solution. You change to CNG, you are able to meet the. I am giving a figure, like suppose a 1.3 liter engine, it emits 150 gram of CO2 emissions per kilometer. If you operate it on CNG, it will emit 118 gram. And 118 is 120 is the regulation. So already you are meeting the regulation of BS6 by CNG. So that's why we are moving towards the alternate fuels, renewable, lower emissions, and we want to resource our reduce our import also. Actually, there is a lot of things to tell in this, but I will develop on some architect how we are using the different fuels with examples. Like in the Delhi, all the city buses, they are operated on dedicated monofuel concept. Means this engine is converted into CNG, designed for CNG. It can run only on CNG. Neither it can run on diesel, nor it can run on petrol. We call it dedicated monofuel. Clear? So you can see all the Delhi buses are on dedicated monofuel. Next come dedicated biofuel. At this moment, there is no dedicated biofuel vehicle in India, but there are biofuel cars. Most of the cars, taxis or private vehicles, they are biofuel but with master slave concept. Master slave concept means they are designed for petrol, and we have a petrol ECU, and then we have a gas ECU. The gas ECU is connected to the petrol ECU, and the car can run on petrol and it can run on CNG also. So this is the biofuel concept. Then dual fuel concept. This is a very interesting concept. Existing diesel engine, you can convert with dual fuel concept. You inject the gas in the intake along with the air and ignite the combustion with the diesel injection. So basically you are substituting the diesel quantity. So suppose diesel engine earlier you were injecting 10 milligram. So you inject instead of 10 milligram only 3 milligram. 7 milligram equivalent energy supply through the CNG. So CNG is mixed with the air and it is going to the engine, and at the end of the combustion you are injecting the diesel to start the combustion. So it remains diesel engine. Same diesel engine can be operated with the dual fuel concept, but there is no practical vehicle on this concept. But now people are working on this. So this is already in the market. This is already in the market. This is slightly futuristic in transport sector. So now, as I told you, you know most of the cars are on CNG now. Even all taxis in Delhi, they are running on CNG. Diesel taxis are not allowed at all. But few are playing, but they have given time for that. And this is the hydrogen car. Now hydrogen, because fuel is not available, technology is not available. So what we have tried, we tried to mix the hydrogen and CNG, and we have run this car. This is a car, green car. This has been developed, and the fuel was supplied from the, we have a collaboration with the Indian Oil Corporation. So there is we have developed a hydrogen generating unit. Hydrogen is generated from the water by the electrolysis of water. It is only for research purpose because cost is slightly higher. So hydrogen is used. Then there is I will show you the filling station also. This is the filling station. Now you have the hydrogen This is the compressed natural gas. They are stored, hydrogen is stored around 350 bar. It is around 250 bar. And there is a blender. Blender is which blend both the gases. And it is blending is computerized. You can feed what is the percentage of blend you need. Whether you need hydrogen 10%, 90% CNG, 20% hydrogen, 80% CNG, 40% hydrogen, 60% CNG. Whatever you will feed it, this blender, this is from USA company, this is a blender which will mix both the gases, and it will, you can directly fill in the tank hydrogen and CNG blends. So this is the first of its kind vehicle which we have operated on hydrogen and CNG, and it was a Swift car, petrol car, which was converted on injection technology, because if you have the no injection technology, it may cause the backfire. These are the same, some important engine aspect, like what is the octane number of petrol, what is the octane number of CNG, what is the octane number of hydrogen, and when we will blend both, what it means. Right? The important thing is ignition energy. One advantage is, like when you burn the CNG, it is very difficult to burn. That is very, you can see CNG car are little bit harder to start. But when you will mix the hydrogen in the CNG, it is very easy to start, because hydrogen is very easy to start. It needs very little energy to ignite. Even if you have a cloth, and with that spark also it can ignite. And the danger thing is, when hydrogen is burning, you cannot see the flame. Everything will be melted. You can't see. If you catch a fire, you can see the flame, yellow flame or red flame. But hydrogen is colorless. The flame, you can just melt down. So you cannot identify there is a fire. You can feel the heat. So that is a very dangerous thing. That's why we have to take the safety precautions. So you have to blend both so that you can get the advantage of the hydrogen and you can overcome the disadvantage of hydrogen. So you are blending the CNG and hydrogen. So this is the filling station I have discussed. Now after filling it, again we have done the chromatography, means we have checked if I have filled the filling wall with the 18%, what is the exact composition. So you see this is the hydrogen 18.6%, oxygen, nitrogen, CO2 2%, ethane 4%. So all this analysis was done. This is the engine management system for the hydrogen and CNG blends. Like you have petrol ECU, all TPS, which I have discussed with you, TPS, ECT, current position, map sensor, all are there, input sensor. Then you have CNG ECU. And this, there are two injectors. Like this is the petrol injector. If you are operating with petrol, petrol is injected through this petrol injector, and there is a gas injector. This is the gas injector. Gas injector is operated by the gas ECU. You are controlling the gas temperature. You are controlling the gas pressure. At what pressure? To control the gas pressure, there is a pressure regulator which maintains the pressure and which is supplied to the gas. It is the gas tank, hydrogen and CNG. It is the filling valve. You can fill it directly. And suppose hydrogen CNG blend is not available, you have another filling valve where you can fill the CNG. So CNG filling system and hydrogen filling systems are different. You cannot fill the hydrogen through this valve, CNG valve, and neither CNG with hydrogen valve. From here you cannot fill the CNG.
and from here you cannot fill the hydrogen for the safety reasons. And then whatever blend you use 18% or 19%, then you can test the engine and you can run the engine and you can see the drivability. One important aspect I am telling you, when we have mixed this hydrogen with CNG, engine become very silent. When you are started in idling, and if you are standing near the car, you are not able to see whether engine is running or it is not running. It is so smooth. So because the hydrogen is having very high flame speed, there are two very important aspects of hydrogen which I would like to tell. One thing is flame speed is very high. Number two, ignition energy requirement is very, very low. Number three, you can use very high compression ratio with hydrogen as a fuel. Its octane number is 130. So you can increase the compression, but the problem is because the density of the hydrogen is very, very low. If I use the same cylinder which I have shown you, you can see that CNG cylinder, I can have only maximum 1 kg of hydrogen. Maximum. CNG I can have 10 kg, but of hydrogen I can have only 1 kg. So my traveling distance in the same cylinder is reduced drastically. In 1 kg hydrogen, the vehicle can go, because calorific value is very high of hydrogen. Do you know what is the calorific value of CNG? Well, when you are studying the alternate fuels, let me suggest to you, you know all the properties of the different fuel. Petrol, what is the property? What is the property of the CNG? What is the property of the LPG? And in property, when we are talking about the property, what is the octane number? What is the calorific value? What is the air fuel ratio? What is the density? So all these things, what is the flash point? What is the ignition energy? At least you should know who the engine who are working or who are interested in this area. CNG has a calorific value of, like whenever you are talking, you ask some taxi driver, oh, my mileage is very good. Your CNG you are getting in kg. I tell you, there is a lot of myth. People are not able to understand. They say LPG में गाड़ी एवरेज कम आती है, CNG में ज्यादा आती है. ठीक है, CNG में ज्यादा आती है, but at the same time you are buying a CNG in kg. So 1 kg of CNG has the more calorific value, energy content, than the 1 liter of petrol. But I am not buying the petrol in kg. Are you getting me?
Yes. Yes.
So basically, if you check the amount of energy you are buying, that is less in petrol. In petrol, calorific value is
48.
In petrol, in liter it is, in kg it is 44 megajoules of petrol, but in kg, in liter if you see it is around 34. So if I am buying petrol, 1 liter of petrol, it is approximately 34 megajoules. But CNG, in 1 kg CNG, calorific value or heat content is around 48 megajoules. In CNG it is 48 megajoules. So I am having more energy. If I am having the more energy, so I will go more. And this you can understand. Nobody, hardly few people stress on this, because if you go deeply, then you can understand this. And again the LPG, they say LPG is good, because the LPG they are buying in liters. When you are filling the LPG, LPG is filled in liters. And LPG in liter because you are buying less calorific value. And otherwise also LPG has the less heating value also. So calorific value is also very important. So all these properties you understand what are different alternative fuels. And one thing is, you can understand why I am using alternate fuels, because they have the property of lower emissions.
Why lower emission? Because they have the less carbon content. When I am talking about that it is the era of gaseous fuels. So it is the era of CNG, era of LPG, it is the era of hydrogen. Hydrogen may be declared as the future fuel. Because hydrogen you will produce. So no CO, no CO2, no hydrocarbons, but NOx is there. Because NOx is the function of the temperature. Because NOx is formed because of the nitrogen available in the air. And oxygen is also available, the both react. So only you have to control the NOx, which is easier as compared to controlling all these parameters. Right? So this is clear to you? So this is a hydrogen and CNG mix master slave concept. So you have a master issue of gasoline and then CNG or hydrogen, and this is the gas injector and this is the petrol injector. This is the real-time data acquisition system. The vehicle was running on hydrogen and CNG blends, and we have used 18.6% of hydrogen in the CNG. Some like electronic fuel injection system, I told you that is the only solution for this. In carburation, you cannot use this technology. Let me see something. Because when you are blending with the hydrogen, one thing I forget to ask you, when we discussed that there is idle stability. Now idle fluctuations are there, I told them you, and the reason you have to find out. Number two thing is, if there is a variations, how to measure that? Number two, what is the specification I should lay it down? So a terminology is used which is known as coefficient of variation in idle speed. And when I am designing the engine, I keep a target. My coefficient of variation should be less than 8%. So I measured 1,000 cycles variation, then I found out the standard deviation, then I found the COV, and then I decide whether this fluctuation is acceptable or not acceptable. In hydrogen, very interesting phenomena occurs. When we have blended this, you see coefficient of variation was drastically reduced. In petrol, it was 0.9. In CNG, I told you, fluctuations are more. And in CNG and hydrogen blended, it is almost half. Because of the combustion is improved significantly. Flame speed is very high of the hydrogen. Now you look at the HCNG system integrated in the car. On the left side, you can see this is the pressure regulator, because in a tank the pressure is around 200 bar. The function of this pressure regulator is to convert the 200 bar pressure into around 5 bar. And because when you are changing the pressure from 200, there is a diffusion is taking place, so it gives the chilling effect. To avoid the freezing of the gas, we are circulating the hot water around the pressure. This is the hot water coming from this is the inlet, this is the outlet. This water is circulating around the pressure regulator so that it can avoid the freezing of the gases. From here, the gas will go in the injector, and then it is supplied to the engine. And in the gas rail, we are monitoring the gas injector rail. It is the pressure also and temperature. Gas pressure and gas temperature both are monitored. In the vehicle here, we have put a hydrogen and CNG
filler valve. So directly you can put the nozzle and you can fill the hydrogen gas. So with here you cannot fill the CNG because it is specially designed for hydrogen. Because hydrogen density is very low. The threat is even if CNG is not leaking from any part, with the same spec of the part, hydrogen will leak because it is very thin. It can escape from the very small tolerances also. So it is very challenging to develop the injector for hydrogen, pressure regulator for hydrogen. This. I don't know, but it is in my laptop. I have a film, a video film of hydrogen engine, which is running on hydrogen. It was a genset. We have done this in IIT Delhi. And there was a 5 kilowatt Honda genset, which is converted into hydrogen. So we have converted that to complete engine management system, injector, and all these are mounted. But that is unfortunately, I can show here that is not a problem, but that is a film. If we can see next time also, if time permits. And this is the, you see, you need special steel tube to carry out the hydrogen. Steel tube for gas supply. This is the what cyclic variations is. You see, this was a 1.3 liter engine and idling speed, suppose I want 750. Can you see if I have monitored for 100 millisecond or 1 minute, how the speed is fluctuating? Can you see? With blue line with CNG, is it come up, down, up, down, up, down. Speed is not constant. This is the RPM, this side. Up, down. But can you see, red one is when I have added the hydrogen. So when we have added the hydrogen, this is, fluctuations are reduced. And I cannot see it here directly, but with the method of coefficient of variation or standard deviation, I can calculate what is the level of variations. That's why we need those techniques. Coefficient of variation in idle speed with HCNG, it was very low as compared to petrol and CNG. Then idle emissions, you can see which this is the CO. See, when it was in petrol, CO was around 200 ppm, mean 0.2%. With CNG, CO was reduced because carbon was less. With hydrogen, it is further reduced. You see, negligible CO because it is the blend of hydrogen and CNG. Now here you have the hydrocarbons. You can see here hydrocarbon emissions. Again in hydrogen CNG blends, it is reduced, and NOx is negligible because it is idling case. In idling, NOx is not produced. Then in petrol, CO2 emissions are around 15%, CNG around 13%, in hydrogen CNG again reduced to around 10%. So CO2 emissions is also reduced. This is mass emissions when you are testing the vehicle on the chassis dynamometer. So this is in gram per kilometer. So CO is also reduced, HC is also reduced, but you can see on the chassis dynamometer, NOx is slightly increased. So this is the, I thought that this is all experimental work, which is very futuristic. At this moment, no vehicle is running on this, but some prototype has been built up on hydrogen and CNG and pure hydrogen also, which are under trial. It is a proto trial. Maybe 3-4 vehicles are there in Delhi, which we are testing. There are 2 filling stations. One is in Delhi, but it is for research purpose only. It is not commercially available. And we are trying to run for some 20,000 kilometers, then take the feedback and then take the technology. So with this, I think we can 2-3 minutes we can have some question and answer regarding the alternate fuels. If you have any query, basically I can summarize also that there are different alternative fuels like ethanol, methanol, LPG, CNG, biofuels, hydrogen CNG, and LNG, liquid natural gas, is gaining popularity in China and other things because the distance covered in CNG vehicle is very low. So if you store it at in liquid state, which is cryogenic, you have to maintain a temperature of around minus 184 degrees Celsius. Then you can store more quantity of gas and you can run a bus for 500-600 kilometers. Otherwise, you are running for 100 or 120 kilometers. So LNG is taking popularity, especially in China. They are doing a operating a lot of fleets also on LNG. In India also it is initiated. And then hydrogen. Before hydrogen come to the fuel of the future, we are blending the hydrogen and CNG. And the important aspect is when I am going for the alternate fuels, I should understand what is the properties, physical and chemical properties of that fuel. What is the octane number, what is the ignition temperature, what is the calorific value, and so on. And based on that, I have to modify my engine. I have to modify the engine management system. I have to modify the fuel storage system. Right? And definitely the era is from liquid fuel to gaseous fuels. And then from gaseous fuel to next era will be on energy. Energy means directly electron, proton, and neutron. You are running your car directly on like electric vehicles, or next era is directly from the cosmic energy. So that is the future. But in this era, I think after 30-40 years, the domain of alternate fuels will be play an important part, and they will occupy a good percentage. Now it is almost 10% of the total vehicle, but it may grow up. Any single fuel will not grow because nobody can substitute the petrol and diesel. It is some part may be biodiesel, some part may be CNG, some part may be LPG, some part may be hydrogen CNG, some part may be electric vehicles, because so everybody will contribute in small ways. So that is the future trend of the automotive. And with this, I close my talk, and I thanks all of you for patience in listening. And if you have any questions, now we can try to answer. Otherwise, if you have some time, any clarification you feel that I have to clarify, or you need to gain some knowledge in the area of engine management system or alternate fuels, or anybody want to undertake a project in this area, they can contact the professor, and we are in touch and we can try to help you out. Yes, anything? Any question? Question?
Any queries from any of the nodal center? JIT Jodhpur.
करो ऑन करो उसको। अरे फिर चले जाएगा, फिर वही दिक्कत है। हाँ भाई, किसी का कोई डाउट? अरे कोई नहीं बैठा है।
JIT Jodhpur, sir, do you have any query? Mic is on. Please come close to the system.
Hello. Hello.
Yes, sir. Continue. Chaitanya College of Engineering. Any query?
Any question from the studio?
So as we know, the penetration property of the hydrogen is very high. So how to store the hydrogen?
नहीं आपने क्या पूछा?
How to store the hydrogen?
नहीं आपने खास
Penetration property of the hydrogen is very high. Penetration.
penetration leakage. So we are using the special material that is generally SS stainless steel, or there are carbon fiber cylinders are used to store the hydrogen. So there are two techniques, and already these cylinders are now available to store the hydrogen.
So why we not use the hydrogen cars for commercial use?
Because storage technology is available, but gas is not available, hydrogen. If you are producing out of the water, then you are spending more energy what you will get out of the hydrogen. It is not economical. The cost of 1 kg hydrogen is 600 rupees per kg. So it is not available.
Sir, internal combustion chambers which design करने पड़ने सामने से.
No, that is the whole engine design will be there. That is one part, but that engines are available. But I think, suppose I design the engine also, and if fuel is not available, and it requires a lot of 1,000 crore rupees to design engine, and then fuel is not available, then what I will do with that design? So first thing is, explore the availability. Some Canadian company, they started and they claimed that we can produce and we can give the commercial hydrogen at a very cheap rate. So they are claiming that we are able to produce the hydrogen by using the solar energy, because artificial means will not serve the purpose. So because solar is free energy, so and in the sea they have put a plant in the sea, and water is also free of cost available, solar is also available, and then they claim that they are capable to develop that technology by seawater. They are able to convert the water into hydrogen, and that they say it may be around 100 rupees per kg. So 100 rupees per kg is good cost, because 1 kg of hydrogen can give you the calorific value equivalent to 3 liters of petrol. So if 3 liter petrol, I say it is 60 rupees or 70 rupees, 200 rupees. And 1 kg hydrogen, same energy, 100 is, even up to 200 rupees per kg hydrogen is, balance out the price of the petrol. But 600 rupees per kg is, at this moment it is too much. Maybe in future it may be viable economically. But technically also some work is done. People are working since the last 20 years, work on hydrogen. But the technology is not mature. It is in, nascent stage.
So how to sort out the choking problem of gaseous fuels?
By providing a heating around the pressure regulator. Choking means freezing, na?
No sir, अगर आप ऑटो में देखेंगे sometimes वो बंद हो जाता है, तो वो हम लोग को सीएनजी वाले ऑटो में बाहर जाता है और एक वॉल्व ओपन करता है, फिर वो रिस्टार्ट होता है, चोक कर जाती है
गैस चोक कर जाती है.
Choking phenomena.
A choking phenomena वही है, it is due to freezing. Because when you are converting, because the cylinder is stored at gas is stored around 200 bar in the tank. And in the engine when it is going at 1 bar. So when you are converting that high pressure into low pressure, then due to the expansion coefficient, the temperature go down very low. It goes below 0. So at that time, gas choking takes place. So generally, what we do in the car and all that, we circulate the hot water around that. Then choking will never happen. We call it choking, or it is a choking due to the freezing or due to the lower temperature in the line. So the solution is already there, but auto is very cheap community. They use a little bit lower technology, but that solution is already available.
तो क्रायोजेनिक्स में तो -180 टेम्परेचर रहता है, क्रायोजेनिक कंडीशन में तो -180 के अप्रॉक्स होता है, तो चौकी का जाना चाहिए.
Choke, that is आप समझ नहीं रहे, दैट इज स्टोरेज प्रेशर।
गैस को लिक्विड स्टोर कर रहे हैं।
आप थोड़ा डिफरेंशिएट करो चीजों को, है ना, हर चीज में इंप्लीमेंट करो मत करो। -140-84 टेम्परेचर ऑफ द स्टोरेज, जहां पे गैस स्टोर करते हैं। जहां पे मैं इंजन में यूज करूंगा वहां पे क्रायोजेनिक नहीं होगी, वहां पे तो टेम्परेचर ऑफ द गैस में भी अराउंड 10-12 डिग्री सेल्सियस आई हैव टू अचीव दैट। आप समझ रहे हो आप, बिकॉज यू आर मिक्सिंग दैट। आप सोच रहे हो जो स्टोरेज में टेम्परेचर होगा वही इंजन में होगा, नो। अब सीएनजी में भी क्या स्टोरेज प्रेशर 200 बार है, बट व्हेन द गैस इज गोइंग इनटू द इंजन, देयर द प्रेशर इज नॉट 200 बार, देयर द प्रेशर इज 1 bar, so it is converted. Similarly, the temperature of -184 will be converted into lower pressure and higher temperature. The idea of the storage is so that I can store more and more gas. Anji, so what do you feel, your neuron has some changed, some synaptic weights are changed? आवाज कुछ कम आ रही है, so good, like if the people are interested they can continue this. This is the area of future and you can follow on.
Is there any question? Hanji? Okay. Question तो नहीं और? Okay. Okay, so on behalf of our institute, I thank Dr. D.S. Khatri very much. He has given a very in-depth and fruitful 2 lectures on 2 different topics, very important topics, and he has dealt them with the, I must say, in a depth also as well as in very interesting manner. So sir, I thank you so much. So I hope that in future also you will continue to give us your support.
Definitely.
Thank you. So tomorrow we will then meet again at 10 o'clock in the morning here for our next session on challenges to automotive industry, performance and emissions by Mr. P.S. Virdi. So we break for the day. Thank you.